Sir, it's our pleasure to have you here, sir. Thank you so much for gracing this occasion. Sir is the Industry Commerce, Investment Promotion and NRI Affairs. Sir, it would be great if you could come over and honor the dais, sir. Please come over. Thank you so much. Satya, can I have you on the stage? Satya is President of VLSI Society of India. Satya, I would request you to honor Sanjeev Arora, sir. Satya. Thank you so much, sir, for making it happen. Sir, I would request you to stay on stage for some time, sir. We would be doing the lamp lighting and all. I would request you to stay here, sir. Thank you so much, sir. Can I have Neeraj and Rohit on stage, please, as well? Next, I would want to welcome Hitesh Gar, Country Head and Vice President of NXP Semiconductors. Hitesh has been our great supporter for anything that we do from VLSI Society of India, starting from VLSI Design Conference, last year VDAT, and everything that we do from VLSI Society of India and for the semiconductor as the vertical. Thank you so much, Hitesh, for making it. Would request you to be on the dais for some time, Hitesh. I'm now requesting Kamaljit Singh, sir, Director General Semiconductor Laboratory. Kamaljit Singh, if he's around from SCL, or please come over. I think he's... Kamal could not make it, and then you're here. Thank you so much. So I mentioned about 5 universities coming together. So now IIT Mandi, I request Professor Animesh. He has been a MM-wave ICs and electromagnetics person. I'm requesting him to be on the stage, Professor Animesh. Next, I'm requesting Professor Rajesh Bhatia from PEC. Please come over. Okay, Rajesh could not make it. Arun is here. Thank you, Arun. Thank you. I'm requesting Manpreet Singh Manna, from Vice Chancellor from Chandigarh University. Thank you so much for making it, sir. You've been a great industry partner, and then we would do more with you. Please come over. From Chitkara, I request Shivani, come over, Shivani. I know you've been part of the organizing team also. Thank you so much for making it. And we have a great support from Chitkara. Come. So just to tell you, all the 5 universities have come together to make these kind of the events happen, and we provide a neutral platform to ensure that these efforts are taken to the next level, sir. So now, just to mark the inauguration, I would request all of the delegates to go up to the lamp lighting and then can do the lamp lighting, please. Please come over, sir.
Sarah, please set your camera, please.
you so much. So from IIT Ropar, we have IIT Ropar Director Rajiv Ahuja online. Thank you so much for joining, sir. Sir, from your institution, you have provided the great support. We do have Neeraj, Rohit, and all the other people supporting us to make this event a grand success. Thank you so much for hosting and supporting this event, sir. Sir, now we would request you to start the welcome address and your address, sir. Rajiv Ahuja, sir. You are able to hear us?
Yes, I can hear you. Can you hear me?
Thank you so much, sir. Thank you so much for joining. You could start your address.
Yeah. First of all, I will congratulate all of you for this event, and it's a very timely event. And I will also like to thank Sanjeev Arora ji on behalf of IIT Ropar, as well as the director of IIT Ropar. And I can see that Dhaka ji is sitting also there. So Dhaka ji, welcome. I could not come in a physical mode. Actually, I was supposed to be today in Sweden, actually. But somehow some program changed. Now I'm in Chennai, so I could not join physically. But as we talking about the VLSI, this is the right time actually, and this is aligned with India's semiconductor mission also. And as we are very close proximity to SCL, we have actually perfect ecosystem, and which can be helpful for the semiconductor industry, especially in this area, in Mohali, Chandigarh area, and we are close proximity to Himachal and other northern state. So we are in a right position actually, and this is a right topic what we have chosen, this is a 29th workshop. Uh, and keeping in this in mind also that we have also started even this year BTech program in electrical engineering with focus on the VLSI, with a specialization in VLSI, just BTech 4-year program on VLSI. So this is align the need of the nation right now, and we now want to have a fab facilities in India, and 2 or 3 fab facilities are coming in India. For example, one in Gujarat and one in Guwahati, close to Guwahati in Assam. But the Micron is coming. There are big giants are coming in India, and we need a skilled manpower also. So if you look at the Indian semiconductor mission, what we are talking, and then for these 2 fab facility, I was talking to the CEO, Charan Gurumurthy of Tata Electronics. He told me that we need by next year 1 lakh people trained in the semiconductor, for the trained people for the semiconductor industry, and we don't have that kind of skilled manpower in India right now for that particular industry. So we have to create more engineers or diploma holders, even ITI. They told me if I know somebody from ITI, they want to hire him. So this is the right time, and this kind of platform will give us opportunity not only to interact with all the big name in this field. I can see there are a lot of names, and I welcome all of you here in Chandigarh. Actually, I told Rohit maybe we should do this meeting in IIT Ropar, because I want to show all our guests how IIT Ropar is growing, and what kind of ecosystem we have at IIT Ropar. And I'm very proudly to say that IIT Ropar is the fastest growing IIT right now in out of 23 IITs. And the way we are growing, I have no doubt that we will be very soon will be one of the top IIT in India, including all these 23 IITs. And this is because our faculty or our young student or our young faculty or young student, so they're keen to deliver, and that's their dream also. So with that, I will also like to say that when we talk about IIT Ropar, semiconductor is one of the area, and when they are setting up a different center of excellence for semiconductor, one of the center is coming to IIT Ropar, which is in the packaging, which Rohit is going to lead that one. So we are aligned, as I say that, and another thing is also that we are part of the quantum mission of India, and again, when we are talking about semiconductor, we cannot forget about the quantum technology. So quantum and semiconductor, they are all linked actually, and the manpower which we need, we have to provide. Want to closely work with SCL. I think Kamaljeet Singh ji is there, and we are buying now this. We have applied for a grant which we call Sathi, and for Sathi, basically we are buying those equipments which were needed for the semiconductor industry. And we have already talked to SCL that they can use those kind of facility, which is almost 60 to 80 crore facility. Those things what they are using for sending the samples to the Singapore, they can send to IIT Ropar. So we are developing this kind of ecosystem, what we need for the semiconductor industry in Ropar and around Ropar. So I will request also, because Sanjeev Arora ji is here, that from the Punjab government side, that we should think in this direction also, and how we can work with the Punjab government, and we can take this to this next level. And we want to make this Mohali area as a semiconductor hub also. So I will not take much of the time, and I will like to say that there are a lot of young students are joining. I always say that this meeting is basically for the young people, so they can start a new collaboration, and this kind of workshop give them an opportunity to work with the expert in the field, interact with the field, and they should create a collaboration. And because we are missing a lot industry academia collaboration in India, but I'm coming from Sweden, where I'm staying for last 32 years, where industry and academia works too closely. Why not in India? How we can bring them in the same platform? And this is the right platform right now, what we have, and how we can work together, industry and academia. So we have to think in that direction. And if we want to make India as a manufacturing hub, we have to think on this line. And it's a responsibility of all of us to work in this direction. And with that, I stop here, and I will like to congratulate all of you, especially all the organizers who are organizing this. And this 3-day meeting will be, a workshop will be very fruitful for especially our young people and for the future collaboration. And I wish all the best to all of you. And thanks everyone who came here. Unfortunately, I cannot be there in a physical mode, but we are on the behind. We are want to work with all of you, and we welcome you to IIT Ropar and especially in Chandigarh area, and hope you will enjoy the hospitality of the Punjab. And Punjab is known for its hospitality and the food. You will enjoy the food and hospitality of Punjab. So thank you, Rohit, and taking care of and asking me to come and to address in this meeting. And with that, I stop here. Jai Hind, Jai Bharat.
Thank you so much, Rajiv sir. Really, really appreciate you joining. Definitely, we are here from industry, I would say. I mean, you did see NXP country head here, Hitesh already here, and I work for NSS, and my colleague is also here. So we are in the right track. As you mentioned, industry and academia coming really together and then making things happen for all the academia world. Thank you so much, sir. Now I request Professor Manna sir, Manpreet Singh Manna sir, please come over here. He is the Vice Chancellor of Chandigarh University. Request him to say a few words.
Very Honorable Shri Sanjeev Arora ji, the Cabinet Minister for Government of Punjab for Industry and Commerce, the distinguished heads of the different government organizations, the top bureaucrats. I could meet our Secretary Sir also, Shri K.K. Yadav ji, who is now Secretary of the Industry and Commerce of Government of Punjab, all my distinguished colleagues from the host institutions, including IITs, PEC, and other institutions, and the very special thanks, gratitude to the supporters. Because of them, today we are here. All the distinguished authors and presenters, though have come from the different parts of my country, India, press and media, the organizers. I welcome on the behalf of my university, being one of the co-host university for this very special event in Punjab, hosting in UT in this special area. Dear friends, it is the right time now. If we will not think today, will not act today, it will be late. I still remember when I completed my engineering in 1993, electrical and electronics. It was my dream to be the part of the SCL at that time. Even I gave an interview. Although there were some other good organizations were there in Mohali, nearby, PCL, I still remember I've been interviewed there. Somehow, my destiny took me to the teaching profession. I joined as a lecturer in Sant Longwal Institute of Engineering and Technology in 1997. I did my PhD from there and MTech from Thapar. And that time, SCL was the name in this whole, Asia, not only country. Everybody knows about it. It does mean that India is always a visionary country. We knew it. The day is going to be there when the semiconductor is going to be ruled. Today, when you talk about any strength of any country, just recall the time when the Ukraine war happens. 35% of our automobiles, the vehicles, they were stranded in the showroom itself. They were unable to sell them. What was the reason? We got a tire, we got a machine, we got an engine, but where to get a chip? And without a chip, you cannot make your car to be run on the road. And similar many more things. See how the RAM cost has been many folds immediately after the war. We realize this. We realize this. And India is always to be the number one to be giving the best technology, the support, starting from the pharmaceuticals, then agriculture, then why not in semiconductor? It is one of the area the whole world is looking for the name of semiconductors. Today you talk about the drones, you talk about the missiles, you talk about the any aircrafts. Everywhere, in a small gadget at home, starting from your juicer, mixer, grinder, or your washing machine, everywhere it is a chip which is required. It's going to be one kind of oxygen for all of us now. So we should understand it. I'm so glad that IITs took a lead. They reach out to the private universities like a Chandigarh University. which is now is 575th rank across the world as per the QS World Ranking. Yes, we are in the top 2% of the universities in this world. So our responsibilities are manifold for that. It is not only to be just getting a rank and to getting the good talent in our campus. It is there to be contribute to the society back. And this is what our Honorable Chancellor Sardar Satnam Singh Sandhu ji always says, serve to the nation first. आपने आज देखा होगा यहाँ पे हमारी वीडियो में हम यही बात कहते हैं, हमने जो कुछ सीखा है भारत से सीखा है, भारत से सीखा है तो भारत को ही देना है. तो अब समय आ गया है. All the great scientists sitting over here, the engineers sitting over here, please come forward. Keep your egos one side, whether I'm from the government sector or from the private sector, whether I'm from industry, whether I'm from academia, whether I'm the bureaucrat. हमें एक होना पड़ेगा. If you know the technology, you know the things, please come forward. We should design together, and the government is with us. अरोड़ा साहब खुद यहाँ पे आए हैं और पूरे समय पर आए हैं और हमेशा ये समय पर आते हैं. जो भी इनके कार्यक्रम होते हैं नोट कर लीजिए, घड़ी मिला के ये पूरे समय पे आते हैं. जब आज की हमारी मिनिस्ट्री हमें ये मैसेज दे रही है कि हमारे ऑनरेबल कैबिनेट मिनिस्टर भी पहुँच सकते हैं समय पर, तो हमें ये समय को अपने पास बांध लेना चाहिए, संभाल लेना चाहिए. थैंक यू सर, आज आप हमारे बीच में आए हैं, आपका हमें बहुत सहयोग मिल रहा है, हमें ब्लेसिंग्स मिल रही हैं. और सर ने 3 दिन पहले एक बहुत हाई लेवल कमेटी भी बना दी है for the whole Punjab universities and the academies. He constituted and taken me as a member. Thank you sir for nominating me. बहुत जल्द हमें एक रेगुलेशन बनाना होगा. We have to streamline the education also in the Punjab. And for that, I am so glad with the government of Punjab. They are doing very nice. NEP इतना अच्छा से implement हो गया हमारे पंजाब के सभी institutions में. IIT रोपर जो पंजाब का है वो number 1 बनने जा रहा है, as our honorable director has mentioned. It means सब कुछ है हमारे पास. अब हमें एक will चाहिए, एक unity चाहिए कि हमें आगे आना चाहिए. With this, I just conclude. Thank you very much.
Thank you so much, sir. I take your words as representing other institutions as well over here. And then we are all here to do things together in a very collaborative way and then make things happen. Now I request Neeraj. Neeraj, come over, please, and then talk about how the whole program went and how many papers and things that you did, and then would you be able to get the program chairs as well? Thank you.
Good morning, everyone. I welcome everyone in this conference on behalf of organizing committee. Before calling program chairs, I'll say a few words about this conference. So this conference, VLSI Design and Test, has been, a lighting torch in the area of VLSI, particularly in India, for last 30 years. So it's the 29th conference which is being held here, and every year this conference would be held in different part of country, so that it can ignite people, it can send a message about VLSI and other related area, VLSI design. And over the years, over 3 decades, the area has transformed itself. So you can see from the theme of the conference that right now we are moving from design to manufacturing, plus including AI and emerging technologies. So this is the theme of the conference, which is changing with the emerging world. So conference has started yesterday. I'll call my colleague program chairs, Dr. Hitesh, Dr. Brijesh, and Dr. Shivani. Please come over the stage and tell the audience about the program and how many papers or what is the kind of schedule and conference. Yes, please.
There is a mistake. It's not my photo. It's yeah. Yeah, it is. This Garg is there. So yeah. Sir, next.
I hope you didn't hijack it actually.
Yeah. Sir, next. So I would like to thank Dr. Brajesh and Dr. Shivani for helping us. So we had almost like 413 papers which we received, out of which 306 got rejected. And we only accepted 26%. We went very strict on the quality wise. you might see like almost like 100 papers we got selected. Go next. Yeah, so there were like all were blind one, and in that 306 papers were at the end, around 22 got rejected. Yeah, next. Yeah, so in that we kept, we made sure that we have at least 3 reviewers in a single paper, and like some paper got 4 reviewers, some papers got 5, and some got 6. So at least for 3 reviewers, we got almost like 53% of reviewers. Thank you. Next. Yeah, so in this best paper award, we chose 5 categories, where like various categories are there, in which we have the sessions also. So I'm not naming it, but yeah, we will have those in the sessions. Next. So thank you very much. Thank you.
Yeah, so in conference also, schedule also, we have yesterday, we have a 12 tutorial sessions that is taken on different fields is there, from the devices also to chip level tap outs also we have. And we have 6 invited talks is there, and 2 keynote talks is also there in the conference. We make sure we are taking more on the circuit side and chip level fabrication side. Thank you. Thank you all.
A very good morning, everyone. Right. The major part has been already covered by Hitesh sir and Brajesh. I just want to add one thing. Actually, it is not the rejected papers. The papers which are selected for getting presented in this conference are the ones which had a higher merit in comparison to other. We had to take a call, right? And believe me, it was a very tough decision. Each one of you, those who has contributed and whose papers are not accepted also, their work was good, but these are the ones which are just the awesome ones. Thank you so much.
Thank you, Neeraj, Shivani, Hitesh, and everyone covering this so beautifully. Now, we all know that investment is key for everything, right? For all the dreams that need to get realized. And we are having here Invest Punjab head, Mr. Kamal, and I would request Mr. Kamal to come and say a few words. It would be very good, sir. Thank you so much.
Good morning, everyone. First of all, thank you very much for inviting us. When Hitesh ji met Minister Sir, me, and CEO Invest Punjab, then he shared that this type of event is going to come up in Chandigarh. And we found that this is a good way to understand this sector, which is obviously upcoming, and a lot of things are happening here in future, for the future generation also. So it's good that in Chandigarh, a lot of things are happening. As already Anchor told that Semiconductor laboratory is here, and that was the pioneer thing which started with semiconductor products and all chips and other things. So now everything is inside that small chip and microchips which are being prepared now. And a lot of students are here who are working on these areas. In studies also, this is a very upcoming area, and I'm hopeful that by this symposium there will be a lot of takeaways which will be helpful in accelerating growth of this sector in future also. Once again, thank you very much for inviting me here, and wish you all the very best. Thank you.
Thank you, Kamal sir. Satya, may I request you now to come and talk about some of the VSI activities and whatever the top activities that you would want to announce in this forum. Would be good to have you, Satya. Satya is the president of VLSI Society of India.
Good morning. Thank you all for basically making this event successful on behalf of the overall VLSI community. I want to thank everybody, especially thank to Sanjeev ji, Hitesh, and Renaissance people. We always get very good support from the industry for this conference and this type of activities, right? See, everybody, wherever we go and talk, we talk about industry-academia collaboration, right? So we thought we'll first start with academia collaboration by bringing the 5 institutes together to basically host this conference. Typically, this conference is generally hosted by one institute. This is the first time we are basically bringing 5 or 6 institutes together in the region to host it together with the intent that the collaboration between them basically will be the starting point, and then basically industry is always there. So I just want to take few minutes to talk about one initiative we are starting from VLSI Society of India called One Tops, one tape out per student, right? As basically people from the chip design field will know is that once a student does a tape out, I think we have erased the industry-academia gap, and student is very much ready to go to the industry and get very attractive and exciting job in the industry much easily. Unfortunately, we are not doing too many student tape outs. So with the intent, basically we started One Tops program where we'll be basically taking the teams from various institutes and guiding them to the tape out in the way we work in the industry. And ultimately, these tape outs will go to the manufacturing and they will get a silicon. Next possible? Yeah. So, we are partnering with basically Global Foundry for this program and other organizations, CDAC, as well as basically Chip2 Startup and ISM. Everybody is basically supporting. And from the industry, I think we got support of almost everybody, including NXP, Renaissance, and all the semiconductor companies worldwide or in India. They are all supporting this program. We are going to be launching officially this program by end of the August. And all the basically faculty members and students present in the hall today or otherwise, right? I think you would have already received the information about One Tops. How many of you have got the information about One Tops? Okay, almost 50%. Other than that, basically, I think we'll be reaching out to you again, and then we'll start the process of basically selecting and enlisting the team by the end of the basically year. With the basically access to the EDA tools by all the institutes provided under the C2S program and One Tops, will create a most unique program in the world to basically do the student tape outs, where they will learn all the skills which are needed in the industry. VLSI Society is doing other thing also. I think in January we have a larger conference in Pune, VLSI Design Conference, which basically attracts about like 2,500 people and India's largest technical conference. So you are all welcome to join us in the Pune for VLSI Design Conference also. So thank you so much. Thank you for all the dignitaries to come, and special thank to all the 6 institutions coming together and making this happen. Thank you so much.
Thank you, Satyam. As all of you know, VLSI Society of India as a body has been in existence for the past 40 years, right? So this is one of the platform that brings industry, academia, and all the government partners together and to make bigger and better things happen. I'm honored to be serving VLSI Society of India as a secretary. Kamal sir, you were referring me as anchor. I should have introduced myself first. My name is Chitra. I work at Renaissance and I do things for VLSI Society of India as well. Okay, now with that, I request Hitesh, come over here, Hitesh. Hitesh is Vice President and Country Head of NXP Semiconductors. As I mentioned before, Hitesh has been a very, very supportive industry leader who is helping us in multiple fronts, I would say, to make bigger and better things for India, for academia, and for running some of the innovative products also. So some of the drives that you do at NXP also, Hitesh, are very, very impressive. And they are the right ones that would put India in the next most watched list, I would say. Please come over, Hitesh.
Thank you, Chitra. Thank you very much. It's my absolute honor to be here in front of you. So very, very, I would say big thanks to Sanjeev Arora Sarji. I got an opportunity to meet him, I would say first time just 10 days back. So, and I think I was kind of amazed with his energy, with his passion, with his drive to do things better for Punjab. He's very new in his role, in this role that he has taken as a cabinet minister. But sir, I think big thanks to you for taking time out. I know how busy you are, but at least putting your attention to the ESDM sector, to the semiconductor sector. So it's my own, this is my home. So I live in Bangalore, but I come from this region. So whatever, I think my push will be also whatever, because SCL was my first company. From 96 to 2000, I was working here. So, and now I just would like to take a bit of a view on how the world is changing around us. So just to see, we all talk about AI. So my story is about where is AI going to go? So where do we see more and more potential of AI, right? And we see the AI, the most potential is at the edge. And that's my story today. If you move to me. So I think autonomous future is going to be the reality, right? We see any sector, be it automotive, be it industrial, we are going towards an autonomous sector. And that's going to be the new reality. So if we see, I think, and also when we talk about autonomous world, there are a lot of things which can be done on the edge. And this is the reality where AI is meeting the, I would say AI is meeting the real world. If we talk about the data, right? So our world is completely overwhelmed with data. So there's a lot of data that we are generating, right? Every minute, every second. So if, so I think if here you see the, I would say 90x growth of data every year that we see. In 2025, I think billions of terabytes that we are creating. How do we handle this? How do we manage this? How do we process this data, right? So now what AI is basically, so AI is kind of, if you see, so human brains are also very intelligent processors, right? So we receive 74 gigs of data every day. If we have to use, I would say the cloud computing for everything, the way we are doing with NVIDIA chips and so everything where this is on cloud. So maybe, can I get a clicker or something? You need to continue moving faster because this is very fast presentations. So I think so basically for intelligent processing, we can't wait everything to be sent on the cloud and processed there. So everything has to be processed there, like we do process in our brains, right? So this is some data which is 500 billion gigabytes of data, which is devices are creating every day. We don't have time to, so then this data has to be sent to the cloud. So if everything has to be sent to the cloud, we need 1000x more bandwidth. And we don't have that, right? Because if there are cars, if there are houses, if there are industries, if everybody is sending the data to the cloud to process, this is not possible. So what we have to do the processing, we have to do the AI, everything at the edge. And that's the future that we are defining, that's the future that we are designing for. If you move forward, right? So when we have the intelligent edge, we have, it's real time, right? So it's not like that you're sending the data to the cloud and then it comes back. The bandwidth problems are not there. Energy efficiency, so for example, how much effort that we are putting, like how much power the NVIDIA chips or the big chips that we have for the cloud computing or for the NPUs they are consuming. But on the edge, it is just 1/10 or 1/100th of the power. So we create very, very energy efficient system. And last but not the least is the trust. You don't want to give your data to somebody else. But if you are keeping the data on your own device, so it is trustworthy. So these four things, be it on the bandwidth side, be it on the, I would say, energy side, be it on the trust side, it makes sense, and also the real time, it makes sense. The data should be processed on the edge. And edge AI definitely has real-time benefits. So if you see energy consumption, I think that is one of, so it's outpacing us. How can we do it? So this is, I already showed that this is going to be 3x needs from 2030 to 2015. So are we ready, right? How can AI solve these kind of energy issues? We need energy systems which are also intelligent, which can think, right? If I am using, for example, my hair dryer, how do I give message to my fridge that you can shut down for 5 seconds or 10 seconds because the hair dryer needs the energy? So how do I build my homes which are more intelligent and we give the energy where it is needed? I think that's what we are looking for so that we don't see those peaks. And also what we see is, so millions of, so when we talk about energy efficiency, when we talk about edge AI, so there are millions of unnecessary fatalities. There are people dying on the roads. There are, I would say, 6 million people with the curable diseases, 2.3 million workplace kind of fatalities. So when we do edge AI, so all these things with autonomous cars, right, with autonomous factories, with agentic AI, we can solve all these things. So I would like to pause here. I think we need to reinvent Vision Zero for all the facets. Agentic AI, edge AI is going to be the solution. And I think NXP from my company, I think we are moving much, much ahead in this. We acquired a company recently in India. It's called Kinara. It's a small company with 80 people, and they are making chips which are 40 TOPS NPU. 80 people making chips end-to-end with the 40 TOPS NPU. And they are, I think, you can do the LLMs, you can do the AI on the edge, right? So we have actually demonstrated the complete LLM for, so there are 16 cameras, so you can actually inference 16 cameras on their single chip. So this is the power, and it just takes 7 watts of power. 7 watts versus 7,000 watts that you have to consume when you go to the cloud. So these are the advancements, these are the things which are going to be, and I would request all the researchers to pay attention to edge AI. How are we doing? How are we making the world which is autonomous? And I think that's where the future is. So with this, thank you very much, and wish you all a very, very good conference. And big thanks again to all the dignitaries here. Thank you.
Thank you, Hitesh. It was so much of data and very, very good presentation. Thank you so much, Hitesh. Now I request our distinguished guest, Sanjeev Arora sir, please come over and give us few words and thank you, sir.
Good morning, everyone.
Good morning.
Thank you, Hitesh, and thank you all the sponsors, organizers for inviting me. I don't know, I think 75 GB has already gone through my head today. I need to take, my brain need to take rest for rest of the day. And I am glad my dynamic officers, Amit Dakha and Kamal Yadav are here. First time when Hitesh came and he was trying to give a presentation to our Honorable CM, I was watching it. Believe me, I didn't know the full form of ESTM. today also before coming, I had to use AI to find what exactly ESDM is. But I am sure I didn't want to look dumb here when I am talking, but still I will be. I know that. But heartiest congratulations for organizing such a good event. All the 5 universities which are taking care of it. It's good that you are involving so many universities, because more universities means more students and more people knowing, because every student who is studying in that university would like to see what their VC said, what their staff said, and how they participated in that. I mean, believe me, this AI and IT is not easy. We saw IIT Ropar Director Rajiv Huja. I mean, housekeeping had still not been to his hotel room from where he was addressing. And he was addressing from hotel room. So you have to get up and start from online and go ahead. Hitesh, who is heading NXP India, again I heard about this company first time 10 days back. But believe me, he was calling me energetic. How much energetic he is, I just saw when he was coming on the stage. He had not reached the mic, he said, "Good morning, everyone." From here. So, no wastage of time. And Manpreet ji, VC of, I would say, university, headed by my previous colleague, of course a friend now also, Satnam Singh Sandhu ji in Rajya Sabha. Whenever we used to meet, we had very fruitful discussion. Amazing personality he is. And whatever you said was very knowledgeable. I agree. I mean, the way this industry is working, I hope this world will never see shortage of chips, what we saw after COVID and war in 3 years. Believe me, the cars, I mean, even the luxury cars which costed like 2.5, 3 crores were selling in black market for 4 or 5. ਉਹ ਕਹਿੰਦੇ ਨਾ ਪੰਜਾਬੀ ਚ ਸ਼ੌਕ ਦਾ ਮੁੱਲ ਨਹੀਂ ਹੁੰਦਾ ਉਹ ਕਹਿੰਦੇ we want this car. So because of chip shortage, the waiting period went up to 12 to 18 months. So I hope, but now I feel there is no shortage of chips, and hopefully it won't happen again with so much work going on. You showed some numbers on papers being submitted and how you selected around 26% of them. But the 74% papers which were not selected, and whoever prepared those papers, I would advise them, keep on using them. In this world, all the failed plans ultimately sometimes became so successful, and there are many examples. So don't lose your heart, keep on presenting those papers. You will be surprised that you may be more successful than the ones which were selected today. I didn't know that, I mean, AI will become the largest energy consumer. It is a surprise for me, but then, because now what is happening in states is quite a few states are energy surplus now. So they don't know where to use. So I'm sure then Punjab needs this industry much more than what we thought, because in coming days we want not even 1 unit of electricity goes waste, and PSPCL makes sure that they bill every unit they produce or they get it on exchange or from wherever. Now, on behalf of Punjab government, I would like to assure you that ESDM is on our priority list. We have already made committee where we have made Kamalji Singh as chairman and Hitesh is member of that committee. And we are looking forward for suggestions. And we have requested all the chairmen and also ESDM that please provide us with suggestions by October 1, by end of September or first week of October, so that we can come up with a policy which will help more and more people come here and invest in Punjab for this sector. Once again, I assure you all that on behalf of my Honorable CM, Punjab government, my department, I assure you of all the cooperation you need to be successful in our state. Thank you very much for having me over. Thank you.
Thank you so much, sir. We are honored by your presence. Thank you so much for your time. Satya, can I request you on stage to present a memento for Sanjeev, sir? Thank you, Satya. Thank you, Sanjeev, sir. Can I have you in stage for a minute, one more minute? Can I have Hitesh come over here? Hitesh, thank you so much for making it and for enabling Sanjeev, sir, attend this event. And I would request Sanjeev, sir, to present the memento to Hitesh. Thank you. Yeah. Thank you, sir. Thank you so much. Thank you so much. Satya, can I have you on stage for some more time? Can I have Professor Manpreet, sir, and Professor Animesh, sir, come over here? Thank you, sir. Thank you so much. Thank you, Professor Manpreet and Professor Animesh, sir, please come over here. As Satya mentioned, we are all doing it together. We collaborate and we make the big thing happen. We have Professor Animesh here. Okay. Okay. So other institutions, we would send it across. And then thank you, everyone. We would continue with the event. So we have a vision address. We would be having corporate VP, Dr. Sharon, joining us virtually. And then she will be giving her keynote address. I'm going to be just talking about her. As we all know, minister and other delegates need to leave. They have other engagements that they need to take care. Now, we will get going with the program. Okay. Welcome, everyone. Welcome, Dr. Sharon. Thank you so much for joining. Dr. Sharon is the corporate VP of AI at AMD. We all know that AI is the most used term of this era, right? And she is here to create a lot of changes at AMD, a lot of changes that we are all going to witness, right? She has been the founder and CEO of Lamini, an AI startup that won last year's VentureBeat Gen AI Startup Award and has been recognized as a Forbes Cloud 100 Rising Star. And she has been a faculty member at Stanford as well. And she has led a 50-person generative AI research group and published award-winning papers in generative AI. She teaches some of the most popular AI courses on Coursera, including tuning LLMs, diffusion models. She has earned her PhD in AI from Stanford under Dr. Andrew NG. And she has worked as an AI product manager at Google as well. She received her bachelor's degree in computer science and classics from Harvard. Okay. So she serves as an advisor in Washington, D.C., and has been featured in MIT Technology Review's 35 under 35 list. Very honored to have you here, Dr. Sharon. Welcome, and thank you so much for staying late. You have a waiting audience over here to hear you. Over to you, Dr. Sharon. Thank you.
Thank you so much for the warm welcome and for inviting me here. Really excited to share more about what we've been thinking about at AMD, and also share more about what I've been seeing at the frontiers and predictions of AI. Let me share my screen. Hope you can see that just fine. So you already heard my bio, but mainly I spent a lot of my time on AI research, as well as teaching AI. So I like to make these concepts really accessible to people. So hopefully you get to learn something from this session. But I spent a lot of my time thinking about how do we use AI to improve AI. Because I really think that AI is actually driving the next generation of AI now. And so it's this recursive and self-fulfilling type of loop that we have going on. So I think it shows up in a lot of ways. So one is you might have seen AI scientists, right? Models actually becoming researchers themselves and actually inventing new things in mathematics, also in physics and chemistry. And so these models have become very powerful. The next side is, these models actually can improve themselves. And I'll go through some examples. One project my team has been working on at AMD is actually using the models to write better kernels, to work better on AMD GPUs so that these models themselves can run faster. So it's a self-improving loop. And finally, these models, they run on hardware and they run on compute. And that's one of the most scaling laws, which is, as an AI person, we think a lot about scaling laws and about how do we get to the next level of intelligence for these models. GPT-5 just came out, for example, and it's a combination of data and the compute underneath it and how to effectively utilize that compute efficiently. So we think about that a lot. And so there's a lot of software hardware co-evolution that happens as a result of future workloads and how AI can improve, but also how the hardware can actually support some of those improvements or even direct some of those improvements. So going into that a little, being able to actually process the largely matrix multiplications for these models. But of course, these models have a lot of different types of computation. I'll go through some of them today of what's going on at the frontier, but also what's going on potentially in the future. There's also different optimized frameworks on top of that. Spend a lot of time on the kernels there, whether it be Triton or HIP or CUDA. And of course, different system architecture. So these models, or at least the lower level layers that we write, have to be aware of the different memory hierarchies and interconnects in order to actually be utilized efficiently, both at inference and at training, especially when it comes to things at scale. So I'm going to share a little bit about what I'm familiar with on the AI side, and I hope this becomes something that's useful to you as knowledge as you build out kind of the future of a lot of layers. Might be familiar, but the Transformer came out in 2017, and it underlies all the major frontier models today. It's the kind of model architecture. And what it does is it predicts the next token or next word, you can think of it as, by looking at every single word before it and all the possible associations before it. So ChatGPT will do that. So for example, in the sentence, the sky is really, and then it has to fill the next word, it's looking at all the past words, and it probably is thinking at some point, oh, an adjective is probably likely because of all those prior words, right? It's probably not an adverb, like really. It's probably not a noun, and it's probably not the word the, it's probably not an article. And blue is probably likely because of the word sky, right? Instead of red, unless maybe something about a sunset was mentioned beforehand or an evening was mentioned beforehand. And so it's doing those associations, not unlike you would or I would do as well. This is really powerful because as the model learns all those associations, it's able to actually learn concepts by predicting that next word. So it actually has to learn that the sky is usually blue unless it's in a sunset. So it has to learn all of this knowledge by just doing this one task. And so this is a very powerful way of learning. And we found that at scale, when we scale it across the internet, it's very effective. So a lot of where AI is going is driven by how users use it and what users want. And consumers, users, that's us, that's you and me. And what we want is usually, bigger context. So we want to add more information to the model, not just the sky is really, we want to add a lot of information about ourselves, about, different documents we have. We want to have a long chat history with it. All of that goes to the model as a bigger context. What's arisen recently is the rise of context engineering. So going beyond just like changing the prompt a little bit, but actually thinking through all the different elements of the prompt, whether it be the system prompt, whether it be short-term or long-term memory of remembering who you are, remembering your session with it, different retrieval systems, of course, using tools in an agentic way. So there's a lot of work now more on context engineering and thinking through what should go into this massive prompt, as well as scaling out that context and prompt. So a lot of pieces go into this now. Okay. So transformers are amazing. It's gotten us to where we are today. It's scaled these models out. But they're also very difficult to scale to larger contexts, even though users want them. So bigger contexts are very difficult because the model, as the context gets really large, is not just looking at a few tokens, a few words like the sky is really, but looking at a ton of those. And each time it needs to recompute all the associations to predict the next word, predict the next token. And so this becomes really like computationally expensive for the model to do, especially when it goes over about 10 pages, which is about 1,500 English words or 6,000 tokens. So this becomes just more and more difficult, and this is an expensive thing to do computationally. It could be where you could consider computational efficiencies, whether in hardware or software. The first one is going to be here in software. So one thing is something called the KV cache. This is used in all of the frontier models today, but it basically means let's store all the past calculations when you have already calculated all the previous associations. So in your chat history, it's almost the same history each time you chat with the model. So instead of recomputing everything, just storing those values that are already pre-computed, and that's really, really valuable in making the computation more efficient. So here with the sky is really what it does is actually, you can see the orange piece. You don't have to really know exactly what all these matrices are being multiplied, but just really focus on the fact that the orange piece is actually cached, and as a result, you only need to do the gold or yellow piece, and that reduces the amount of computation significantly, and that's the main takeaway when you predict the word blue. But there really is only so much memory, so it gets cached, right? Just like a regular cache. It may be, evicted in some way, or you may, fill up the cache in some way, especially as that context grows. So that's not perfect. But essentially, the pieces of the model that are most memory hungry, are the weights of the model. So the model, like just the sheer brain parameters of the model itself, but also this KV cache piece. And both of these contribute to the fact that these models are expensive in memory to run. And something that we think about at AMD a lot is this very problem, and to allow the models to actually be able to run on our GPUs that are very memory rich. So for example, the MI300 versus H100 has 192 gigs of of HBM, of VRAM. So it can fit some very, very much larger models than an H100 and can fit a GPT-3 level model on a single node or on just 3 of those GPUs. So this is really attractive for especially a developer who is working at a scale of like 1 node or even 1 GPU to be able to run these models on a single server. And I think it scales out to a lot of different principles when you think about the hardware foundations for the next generation of AI, especially AI is now like inventing the next generation of AI. It's even more important to support AI in that way. So memory bandwidth is extremely important. They're gonna, models require so much high bandwidth memory, like terabytes per second, essentially. There's also, again, just like a high memory need for a lot of these models, since the larger you make the model, the more data you can put in it, and the smarter it gets. The compute density requirements are fairly dense, just thousands of teraflops. And I think this is well known now, but we're starting to meet serious power constraints from different grids. So different companies such as Microsoft are actually building out their own power plants to be able to handle the next generation of AI. So I think there's a lot of pretty exciting innovations at that frontier. And so I'm excited to see what people build here, but this will enable the next generation of AI. Whether you can 10x any of these pieces will make a very, very, very big difference. On the AI modeling side, so people who are thinking about like, okay, given the fact that these transformers can't scale in a certain way, what are some other ways to think through how we might create a model, right? And transformers are known to do something called autoregressive generation. So that means it generates each word by looking at the past words, right? And as a result, it can actually be slow because it like depends on all the past, right, to guess the future. And instead, there's new kind of training strategies beyond transformers. And one of them is called a diffusion process or diffusion model. And this is really exciting line of work where a lot of images are being generated. And instead of predicting the next word, it actually guesses like a clearer and clearer and clearer picture of something like you see here. It goes from pure noise to something much clearer. And this is very obvious when it comes to images, and it's used in a lot of popular image generation models. For text, what it looks like, and very excitingly, it's been applied to text more recently. For text, what it looks like is the hero blank the day, and first it has something kind of noisy, like words that make no sense, right? Like watermelon controversy. And then it gets to become more and more, it makes more and more sense until you see the hero saves the day. So essentially, it gets that clarity from a text perspective as well. And so as you can see, AI is really driving the next generation of AI. And a lot of these innovations are really important and kind of, in some ways, workarounds for the compute that we have and the models that work that we have. But I think it also is driving AI to be both cheaper, faster, and better. And I'll go through a few of those innovations at the frontier. So one is around, because the transformer is slower at predicting, we can exploit the fact that it's actually really fast at reviewing work. So there's a new, this is not super new, but this is what all the frontier models are essentially doing. It's something called speculative decoding. And instead it uses a small AI to make those predictions, because the small model is much faster. So the small AI is doing most of the work of predicting what the next word is, like the sky is really blue. And then it uses the larger model to review its work, because the model is much faster. It only takes one iteration to go review its work versus each of these predictions for the next word is an iteration. So as a result, it's doing 4 iterations of small here and then 1 iteration of big. So it's much faster to do things this way. And if the small models are wrong, then the big model obviously has to go do that extra work. But this can save a lot of time. And so sometimes when you're playing with a chat GPT or a frontier model, you'll notice that it's suddenly really fast and then slow, suddenly really fast and slow. And that's actually the speculative decoding potentially happening right there. Another innovation that I think has been highlighted by the recent open source OpenAI model is mixture of experts. And of course, other models were all mixed. A bunch of models have been a mixture of experts, but the most recent one from OpenAI was interesting because it's each expert is so small and so fast. But essentially, the premise of this technique is given a very large model, a very large brain. If you ask it a question and you have to use the entire brain to answer the question, that can be quite inefficient. Maybe you can split it up into a team of experts instead and have one expert or only a few of those experts respond at a time. And that'll reduce the amount of computations. You only need to do a fraction of the brain to respond. Kind of like our brains, we don't use our full brain for every single thing that we do and react to. And I'd be very interested in seeing how hardware or memory hierarchies evolve to accommodate kind of a mixture of expert type architectures in the future. And finally, another way to make AI faster, again, I noted this before around kernel generation to make AI faster, and this is a project that I'm really interested in that I've been working on at AMD with my team. But essentially, kernel code, which is the code that makes the model much faster on particular pieces of hardware, is very difficult to write. It's very bottlenecked by key engineers who are very good at writing this kernel code. So instead, can we get AI to write this code, and we can get very large speedups that are in the 10, 20x by doing that and by optimizing for it. And that's AI again using itself to make itself faster. And then for better AI, for these models to actually work better, you probably heard of reasoning. I'm very excited about reasoning and where that's going. Essentially getting the model to think a little bit longer before it responds to an answer. So it uses its own kind of thinking and different tokens to think through different possibilities before it responds. And ultimately, I think GPUs or specialized hardware will make these models be able to go faster, cheaper, and that also means better in the scale of things and in support of scaling laws. So making it cheaper also means that if we can make it 10x cheaper, reasoning is 10x cheaper, and therefore it can reason for 10x longer and therefore give you a better response. If it can be 10x faster, then models are 10x faster, and then reasoning again is 10x faster. So ultimately, what I'm excited about is AI being able to prove AI, but also the opportunities for partnership and collaboration across the ecosystem. Something we do at AMD is we make all our software open source, and we're only going to make it more and more open moving forward. So I'm very excited about the opportunities there. I spend a lot of my time collaborating with different universities, such as my alma maters like Stanford and Harvard, and also teaching there, but research partnerships as well, but all across the ecosystem from Hugging Face and PyTorch to VLLM and SGLang and Triton. And so it's a very exciting time, I think, for AI, and I think the more we do stuff in the open, the more we can share and the more other people can participate and collaborate together. So if you're interested in collaborating, I'm super happy to chat. That is it. That is largely my talk. I hope you learned something there, and if there's time for questions, I'd be happy to answer any.
Thank you so much, Sharon. Pretty impressive talk, and then I like the fact that you're open for collaboration, and there are a lot of students over here and educators over here. I'm sure they're going to be reaching out to you, and thank you so much for staying late and providing this talk for us. Thanks very much, Sharon.
Absolutely. Thank you so much for having me.
Yeah, let's give a good round of applause for Sharon. Thank you, Sharon. Okay, now we move on to the next item. So this is going to be a fireside chat. So we are going to be having Satya do the moderation. We are going to be having this, again, next to AI, if I will have to look at the most talked about topic, it is the 3D ICs. How many of you know about 3D ICs? It's the cutest packaging technologies that the semicon arena is seeing now, right? So we are going to have two experts joining us from US. Again, I'm very thankful for Ravi Mahajan and Wilfred Gomes. Both of them are going to be joining from the US. We'll do a little bit of setup while I introduce them. So Ravi is the Intel fellow, and he is working on multiple cutting edge package technologies and then package related inventions for Intel. And Wilfred used to be an Intel fellow, and now he is doing his startup. He is the president and CEO of this company called Mion Corporation. Yeah. And Satya, we all know he is the technical leader. He has spent his time at Intel, Open Silicon, multiple of startups he did. He is the president of VLSI Society of India also. Just give us a moment while we are setting it up. Thank you, everyone.
No problem.
Can you hear us? Wonderful.
Hello.
Check. Hello.
I can hear you. Yes, can you hear me? Okay. No problem.
Hello.
Hi.
Hi. So good morning, everybody. Hope you can hear us. And after an exciting talk by Sharon from AMD, we are going to talk about a topic which is probably the most talked about topic in the world of semiconductors today, which is the 3D packaging of the ICs for all different kind of applications, primarily driven by artificial intelligence requirement, but also future it will be applicable to all other different kind of applications. And we have basically two of the global experts in the packaging. We have Ravi Mahajan from Intel, who leads the packaging activity at Intel, and we have Wilfred Gomes, who helped in develop the Foveres technology at Intel, and now he is leading a startup in the 3D packaging called Mion Corporation. So thanks a lot, Ravi and Wilfred, for joining us. Hope we are all audible. Okay.
Yes, you are audible. No
Yeah,
problem.
yeah.
So we can start with basically your current view on the high performance computing, that basically what is happening today, what is expected tomorrow, and how is it basically affecting the innovation in the semiconductor and packaging. So maybe we can start with you, Ravi, and then Wilfred, you can share your views. Yeah.
Sure. So I can start by saying that what is important now is being able to integrate heterogeneous semiconductors on packaging as a platform, advanced packaging. And then, even today, we have products which could not have been done 5 years ago because we invested in a lot of important technologies. There are many aspects of these technologies, but the ones that are very important are we able to interconnect in all 3 dimensions? In the vertical dimension, which is popularly called the 3D IC, and then horizontal connections between these verticals. So if you can imagine a Manhattan, with high density streets in between for information on a platform that allows you to stitch everything together. AI is a pretty dominant driver because everybody is focused now on increasing the total amount of compute and total amount of memory with the right networks on a package. And you notice that GPUs and CPUs to some extent are growing, the performance is growing pretty fast, and the need to put it all together in compact form factors is very important. Other issues that matter quite a bit and which will continue to dominate this space are how do you deliver power effectively or efficiently, how do you cool these parts, and how do you manufacture these complex structures very fast with high yield so that you continue to meet demand. And as the previous speaker said, memory bandwidth is one of the important ones. The ability to integrate memory and compute is quite important.
Okay, thanks, Ravi. Wilfred, your point of view, what are the basically innovation and challenges in the high performance computing in general? We'll come to the packaging as a basically subsequent question. But in general, where are we heading? What kind of the innovation happening on the compute and silicon side and other areas like memory and so on and so forth, right?
Thanks. First of all, Satya and the VDAT team, thank you for inviting me. Again, glad to be partnering with Ravi and you. So the questions you asked are very relevant, and I want to build on what Ravi said. Advanced packaging, both 2D and 3D, I think really enable a new class of architectures. And the fact that we can build them both in a heterogeneous fashion has opened up new directions. And let me actually say that they need to actually address 3 very fundamental problems that today's data center high performance computers are facing. One is at the lowest level, memory bandwidth. That is becoming a fundamental issue. Secondly, building large systems. So if you were to go to a data center today, they're connected by miles and miles of cabling. And third is delivering power and thermals at like in a manner where with acceptable cost. So if you look at all these 3 problems, what advanced packaging, both 2D and 3D, are providing is new forms of constructions which potentially have no limit to the kind of systems that can be built. Conventional thinking was a chip is a chip, but tomorrow and in going forward, you'll have large chips, system on a rack, system in a data center. In fact, the way we should think about it is integration at the data center level, where many of the things can be simplified. And the fact that we have some of the building block technologies will enable it. And I think the key thing is, can you actually come up with architectures that could be 10x, 100x better? And if you look at it holistically, advanced packaging is, I think, is a fundamental technology that could potentially enable this. So this is why I'm super excited. So it's not just about, it'll be not about advanced packaging, it'll be also about system integration.
Okay, Wilfred. Can you move your camera a little bit? Half your face is hiding, Wilfred. That's good. Yeah. So, yeah, that's good, right? So, before we go into a lot more intricacies about the packaging, why not keep growing basically bigger monolithic dies, like basically wafer level dies like Cerebrus and all of those things? So, if we compare that basically things that if you can do a wafer level die just like Cerebrus is doing versus what everybody else is doing in terms of basically 2D and 3D, right? How do you see the contrast between the two different way of doing the bigger and better chips?
So if Wilfred, if you want, I'll take a stab at it and you can elaborate.
Go ahead, Ravi. Yeah.
So, when whoever does wafer level system, they really are doing advanced packaging. They are putting known good chips, if you will, and connecting them using wafer level or panel level eventually interconnects, right? It is heterogeneous integration. It is, see, bottom line is this: you can put a certain amount of information on a reticle that you print, and then you can print multiple reticles. On the same wafer system, you cannot put different types of IP. The classic example is CMOS logic or compute logic and DRAMs. They will be different, and you have to stitch them somehow. Even Cerebrus is stitching them. They're just stitching them at a wafer level scale, and somebody will stitch at a panel level scale. They are all using advanced packaging techniques. I don't think you could print a reticle of compute only and expect it to work, because the interconnectivity between the reticles on that wafer has to be managed, and they have to have access to different functions, different classes of IP, memory, and all that kind of stuff. So essentially, this is just large-scale heterogeneous integration using advanced packaging.
Okay.
So maybe I can add a bit.
Yeah.
So typically, most architectures, including AI, they need access to both bandwidth and capacity. So what's going to happen going forward is there is going to be the need for a lot of memory capacity. There's going to be need for power delivery. There will be need for CPU, GPU chiplets. So the way to think about it is the architectures. These are the architectures we need to build. The question is what packaging technology enables all of this. So I think we should stay at a fairly higher level. Today's architectures, whichever you see today, are I think in some ways were constructed before the AI era. The next generation architectures would be very different. They would have to be a really low power, highly efficient, reduced data moment. So that calls for highly heterogeneous integration. Secondly, as Ravi mentioned, there are new techniques coming on from wafer to panel. There are new things like glass and other substrates being explored. So this is a continuum. The industry goes through, there's an intense amount of innovation in the ecosystem. So you need both the right architectures and also the right building blocks. The job of the architects and the system designers to pick and choose the right components so that you can actually build high volume systems that actually can, can be built in volume. So secondly, I think what happens is it's also very important that edge and inference and other mobile applications are becoming very important. So we should not forget, even they need very high performance. So So some of the techniques that we are talking about, they need to be, waterfalling into this other segment. So high performance is a complicated word. High performance in a given power envelope in a form factor is the discussion, and the lower the cost you can actually drive a solution, the most disruptive. So we really should look for technologies that can span a wide variety of users and cost and other profiles.
Sure, sure. If we look today's basically products in the heterogeneous integration, most of them are basically 2D and 2.5D, right? If you look at any of the typical high performance chips, right? You will have memory stack, you will have a computer stack, and then basically compute is not really stacked right now too much, but compute in horizontal and then basically connecting to HBM type of the vertical stack, right? Now, from there to go to basically a completely vertical integration with multiple compute chips and multiple memory chips, all basically stacked horizontally. What do you see basically the challenges currently being addressed by a lot of technologists to make it true 3D rather than basically pseudo 3D?
So, Satya, I don't believe that purely 3D and with no lateral connectivity will happen. Even today, like take Ponte Vecchio as a classic example, and there are others, of course, or even the AMD V-Cache. They are doing fairly, the Ponte Vecchio had 3D with 2 compute elements, and then, as you said, memory next to it. And then there were others where they put stacks of memory. But it has to be scaled in all 3 dimensions. Just scaling in the vertical dimension alone will not suffice, because you have to have access to I/O, you have to deal with thermals, power delivery, all those kind of questions. So it will be a combination of stacks connected to each other through high density lateral interconnects, and the stacks will be connected with high density vertical interconnects. So I think the right mental model is to imagine Manhattans, skyscrapers connected by high density streets in between.
Okay. So just follow-on question to maybe Wilfred, right? Yes, it will be horizontal, vertical, but in the vertical dimension, what are the challenges in putting the heterogeneous? Right now, vertical direction, we are putting homogeneous chips only, right? Basically like HBM stack, right? What are the challenges if I have to put basically, let's say, 4 compute dies and 8 basically memory dies in a 1 vertical tower, and maybe additionally vertical towers by the side of it? That's what you are saying, right? In some sense, right? But I don't see right now too many products or too many technologies which are in the commercial where multiple compute and basically memory are stacked vertically, right? What challenges do you see if we have to do that? Wilfred?
I think there are three fundamental challenges. Well, first, let me address technical. I think mixing heterogeneous in 3D in that manner you described requires a lot of coordination between all those dies, bump pitches, the connectivity. There's a whole lot of just a design details planning, which is very, very complicated. That needs to be figured out. Second is, it's not very clear that one company has access to all the IP that you need, so where you can just put it together in like for example, you may need memory, you may need compute, you may need other things. So putting them all together, complicated. Third is, I want to go back to Ravi said, there are natural breakpoints in architecture, both 2D and 3D. And if you do not actually respect those architecture boundaries, you do not get a good product. The reason memory was able to go 3D was, that there was a vector of improvement that was easy, and it was in some ways like easy to kind of build. Compute is not like that. It's a far more complicated beast. Just because you make it 3D doesn't mean that you'll get any performance. You have to feed it. It's not even clear that DRAM can be very easily integrated in such a stack because of thermal issues. So there's a whole lot of very fundamental topics that have to be solved, from thermals, reliability, who takes ownership for the problems that are caused, design integration issues. And in the end, if you do all that and compare to classical 2D architecture, if the benefit is only, say, 20%, there's really no benefit of doing it. But the flip side is, if you look at the human brain, it's very 3D in nature. It's like, thousands of folds, things are all connected. So maybe in 20, 30 years, we would definitely have a lot more 3D as some of this fundamental issues are solved, because, there is a good architecture out there pointing out, but there are, I would say, some fundamental problem to be solved before we get there.
So, I think, Wilfred, you mentioned that although high performance AI application will driver to develop this technology, but ultimately it has to come to basically more utility chips also, like mobile phone, CCTV cameras and other applications. But at this point, basically, I think only elite people have access to this technology because of cost of the technology and cost of the basically product also, right? How do you think that we will basically able to democratize it further? Because if the package cost is $700 or $800, like basically current NVIDIA chips, right? Then obviously it's not going to fit in the cell phone form factor, or basically a mobile phone form factor, or a Palladium type of the thing, right? So how do you see this waterfall is going to happen, right? Because what are the basically ecosystem dynamics do you see to say that this technology like Foveros, Covas and all of those things basically get more widely used by different applications, which may be like $10, $20 chips, where $700 packaging is certainly not possible, right? So what do you see the evolution of this from a ecosystem and the business development point of view?
Yeah, so that's, I can take, and then I'll hand it to Ravi. So it's not very clear that, every application needs the same technology ingredients to make a case for it. And let me explain. Today, in most cell phones, you have bonded DRAM dies. They're actually 3D stacked, but most people wouldn't consider them 3D stacked because wire bonding doesn't have the same, maybe the technology challenge of a 3D stack. So, but it is 3D stacked because it fits. So the reason I bring this up is between some of this more expensive technologies which require truly 3D stacking, there are some new layers and other other technologies that are coming, which I think can be a good stepping stone towards what quasi like a good the things that you described. But having said that, most technologies need high volume, need infrastructure development, a lot of capex. Just because in the end the technology is cheap doesn't mean that it started that way. It needs some development. So this is where the applications come in. For example, the camera sensors that you talked about, it took quite some time for them to become lower cost and high volume. Even there, I do not think it has kind of waterfall to the lowest cost camera sensors. So I think the market has to identify a couple of key product segments, drive it to very high volume, ramp up infrastructure, and like drive yield and other things to make this happen. So that's some of the things that I think needs to be done. So again, all this is like as a continuum. You don't have to like jump to the highest end. So again, I want to go back to what Ravi said. I think there is 1, 2, 3, but also I won't.
Yeah, and to elaborate on what Wilfred said, Satya, there is an element of need, an element of resolving significant technology problems. A classic example is wire bond was the dominant technology, still is in a lot of segments, but there was a time when people felt you needed area array and flip chip at C4 became popular. It took some time to resolve all the issues, to get them up to volume, to expand the capacity, across the board and find applications. I think the technologies we are talking about today are an order of magnitude more complex. It'll take a while for them to settle. But there are some vectors that will improve the rate of progress. For instance, chiplet with standardized links between die as they apply to different segments will definitely have a Lego block type of effect. So, and these Lego blocks can be used for applications. So there are some vectors that are starting to emerge that is driving this. But right now, at the very high end, most people are focused on solving really, really difficult technical problems. High power density, manufacturing yield, all those class of problems. It'll take time for this to solve, and then it'll settle into and waterfall into areas that need it.
Okay. So I think we have about 5 more minutes left. So one question I had, Intel is leading the one component of this whole 3D ecosystem through the backside power, right? Now, backside power, if I leave aside 3D packaging, just for regular chips, is it going to become basically the de facto technology, and what advantage does it provide to a regular chip if I don't take 3D packaging? Does the regular chip with basically CFET type of the architecture and basically doing the backside power, for regular monolithic chips, what kind of the advantage does it provide? And do you see it is going to become a commonplace architecture for the basically in the near future?
So yeah, that's a very significant question. Let me answer it in this way. For the very first time by doing backside power, you are now using both sides of a transistor layer, and you are allowing the ability to optimize power delivery independently of I/O to some extent, right? So it has opened up a new vector. Now, whether this succeeds will depend very much on the applications that people use it. But think of this as one more option that is being offered, and a very significant option that is being offered. How to use it and how to integrate it is going to be sort of application dominated.
But in general, will it reduce the number of metal layers required for interconnect? Because today, a lot of metal goes for power delivery from top to down, right? Do you see that, can I reduce one metal layer with the backside power?
Probably more than one, but it all depends on design choices you make now. This is just like one more order degree of freedom that is being offered for people who use it or who believe they can use it. And, by optimizing power delivery and I/O independently, you have a chance to potentially reduce layers. Potentially, okay? It's a very design-dependent decision.
Okay. So Wilfred, I think you started a new venture, Muon, for 3D packaging and system level, basically thinking in these kind of the chips. Can you describe what are your future plans and thought process in that direction?
So yeah, thanks for asking. So we are partnering with some of the major hyperscalers, and their challenge right now is building large systems. So for example, when we did Pranavecchio, we had 50,000 GPUs. Now people are thinking about connecting 1 million GPUs, maybe 10 million GPUs. Very difficult to connect so many, power them. This data centers are now in the not just hundreds of megawatts. They may be in the gigawatt. So we want to be the first ones figuring out how to build gigawatt class data centers, like both from a thermals, power delivery, integration. So with the work that Intel and the ecosystem have done, I think there are some really good building blocks. But there is, I think, a need for the next level of integration at the system level, where you can actually figure out how large systems are built, how memory is designed, how power delivery is created. That is what Muon is focusing on, how to make system scale integration, not just build it, but also provide big efficiencies in power and cost. So that's what Muon is focused on.
Okay. Any final words from both of you about the technology, packaging technology? Because a lot of enthusiasts of packaging. Rohit is sitting next to me. I think you guys have worked together. So any
Yep,
final words from
one-
both of you? Maybe 2 minutes each, and then we can close the session.
Yeah, one thing I should point out that we are engaged in driving a roadmap of what the future. You know, ITRS was a very successful roadmap because it helped drive the evolution of semiconductor or transistor technology to a large extent. We are doing something very similar for heterogeneous integration. We have a heterogeneous integration roadmap that is sponsored by IEEE, SEMI, and ASME. That roadmap lays out various attributes very intelligently. And Rohit is part of that discussion. I have a feeling that if we collaborate and we expand this roadmap to, you know, whoever wants to participate, we encourage them to participate. If we all define roadmaps, if we define challenges, if we define where we need to focus, what kind of research must happen, I think we have a lot of opportunity. The opportunity in this field is huge in heterogeneous integration, advanced packaging. And a roadmap will allow us to systematize it and do it right. So I'd encourage whoever is interested to please participate in this.
Sure, thank you. Wilfred, final words.
Yeah, so I think the future of Moore's law is really system integration. And what that really means is materials, thermals, power delivery, and bringing 3D packaging together. Many people think that AI means jobs are lost, programming can be automated, but that's not the case with some of these really difficult problems. When I joined Intel 27 years back, I somehow had this vision that I was maybe just naive. I thought, like the industry will go on for forever because that is how, like we used to read Carver meets. But in the last 27 years, actually the performance has increased by 1,000,000 times. And when I look at the future possibility of system scale integration, I think there's 1,000,000x that's possible in the next 30 years. And that's what excites me about, like some of these things that we are doing and what the other companies, Intel and others are doing. So this is really the future of Moore's law.
Okay. All right, thank you guys. And special thanks for staying very late in the night because both of you are in the Pacific Coast. And probably it is close to 10:30, 11 now, right there. So again, thank you very much. And let's stay in touch and see how we can basically keep developing the technology for the future. Thank you so much.
Yes.
And I think we probably, do we need to take any audience question? Or we are good? Okay, so we are good. So Rohit is saying hi to both of you, and I think we'll close the session with basically this thing. Okay.
Yes, thanks for the
Thank you,
opportunity.
guys.
And
Bye-bye.
Rohit, keep up the good work. We are looking forward to participation from all of you guys. So.
Okay.
Yep. Bye-bye.
Bye.
Thank you.
Thank
Good
you.
night.
Thank you. Yeah.
Thank you, everyone. I invite Rohit for formally providing the thank you note for the inaugural session, and then we can take it from there. Students over there, please pay attention. We have following sessions. We have following keynotes coming up. Keynote by CDAC Executive Director. We have Sudarshan here, and we have invited talk by Gaurav of Renesas and Ganesh of Open Power. Students and all participants, after this thank you note, please get back after tea, okay? Over to you, Rohit.
Thank you, Chitra. And I was supposed to say a vote of thanks and then open the house for tea. Looks like the tea has already been served. But whoever is listening, most of you are busy with tea and all. But it takes a lot of time to plan an event of this scale and this complexity. In the morning, you heard, 5 or 6 units coming together, SCL and 5 universities. It adds to the confusion, right? There's more people, more confusion, so to say. But in our case, it was very coordinated. It was, it was a seamless team. And I probably might miss a few names here, but thanks all of you for pulling this through. starting from the whole team from different universities. From Chitkara University, we have Shivani ji, we have Ruchika ji from Chandigarh University, we have Alpana madam from Thapar, we have SCL, Dr. Kamaljeet and his team himself, and then of course IIT Mandi. I don't think Hitesh is here, he's busy sipping tea, but Hitesh and Professor Behra, we had a lot of people from, and of course Peck, Arun will sort of, catch hold of me, but Arun and Professor Bhatia, they were so kind of, providing all the logistical and other supports. But there are few people who sort of stand out here, and it would be unfair to not thank them. One of them is, of course, all of this is money matters, right? At the end of it, it's all money, right? And our sponsors, they have given money. Academic institutions have given money. But the person who sort of managed all of this and was the person taking care of the purse was Dr. Sakre. I think he's also busy somewhere having tea, but he really has been keeping a tab on expenses and doing that thankless job. So that was very important. Dr. Brijesh Rawat, Dr. Hitesh Shrimali, Dr. Shivani Malhotra, they have been helping us with technical program, getting the reviews done in an unbiased, unfair manner. In a fair manner, sorry, and also, 20 odd percentage is as good as a journal publication acceptance rate. So, that is very important. Thank you very much. And, we have these veterans, if I can use that word, rather I would use the word of being banyan tree, anyone comes under their shade, they sort of get benefited. Satya, Chitra, Professor Virendra Singh, Professor Sudeb Das Gupta and all. They've been, guiding us, do this, don't do this, this will not work, this will work. And probably those are some of the learning, inputs because of which we could, come up to this stage. Last but not the least, I wanted to thank two individuals who have done an amazing, amazing job. No amount of thanks can sort of, be an equitable, explanation to their contribution. One is Professor T.V. Kalyan. I think he's not in the room probably, and the other is Professor Neeraj Goyal. So both of them have been, steadfast in, countless calls, messages. Neeraj is there, as you can all see. Kalyan, I can see now. Professor Kalyan? Professor Kalyan? Yeah, so he is right there, and thank you so much for both of you for your help, support, taking this through, being a binding force, right? So with all of this, you're already broken for tea, so what should I say? Those who are still listening to me, let's have a cup of tea and then we come back in. Within 10 minutes, we come back for the next session. Thank you.
Hello. Yes, good morning again. Next session will start in 2 minutes. Please finish your tea and coffee and come to your seats. We'll start the session in 2 minutes at 9:55, 11:55.
Oh, okay, okay, okay. Oh, sure. So that was like the first version of the LA. I also felt the first version.
I request everyone to kindly be seated for the next session. Please be seated for the next session. Requesting all the delegates at the back, kindly take your seats. We are about to commence our next session. A very good afternoon. I'm Dr. Navneet Sehgal, Professor, Chandigarh University, and I welcome you all to the 29th International Symposium on VLSI Design and Test, VDAT 2025. As we gather for this landmark event in Chandigarh, supported by the VLSI Society of India, today promises a vibrant exchange of innovation, knowledge, and collaboration in the world of electronics. Up next, we have a lineup of keynote address and invited talks by some of the most influential minds in semiconductor ecosystem. We are joined by Dr. S.T. Sudarshan from CDAC, who will take us into India's advancement in high-performance computing. Allow me the pleasure of introducing Dr. Sudarshan. Dr. S.T. Sudarshan has over 3 decades of R&D experience in India as well as the United States, and a wide expertise in various technology domains. His areas of interest includes semantic mining, big data, HPC, cybersecurity, IPR, technology management, strategic management, and emerging technologies. Dr. Sudarshan is currently heading CDAC Bangalore as Executive Director, where he is overseeing the development of quantum technologies, Chip to Startup program, EDA, tool grid, etc., among other technologies. He has been honored with prestigious awards like FDA's Outstanding Service Award, FDA's Group Recognition Award, and many more. Ladies and gentlemen, it is my privilege to call Dr. Sudarshan, Executive Director, CDAC Bangalore, to present his keynote address. Sir, please.
Namaste. Good morning to all of you. So happy to see VDAT coming to Chandigarh. As was highlighted during the inaugural session, that for the first time, we all know Punjab for 5 rivers. Now 5 universities and academicians came together to run this VDAT conference this edition. And Dr. Satya Gupta and Chitra Madam, they have been spearheading it tirelessly for, I will say, generations, this particular conference. Thank you once again to Dr. Satya and Chitra Madam, because they seem to have the knack of getting everyone on stage by creating the right interest, which we saw with the Honorable Minister himself coming and supporting the event, along with, of course, our IIT Roper Director, Vice Chancellor, and our good friend NXP Hitesh Gargji. And today, as I speak in front of you, first of all, I would like to thank you for joining. In view of the slightly changed schedule because of the Parliament session, perhaps I will cover a little more than what was my original agenda, because as CDAC, we also in a way represent Ministry of Electronics and IT, who is leading the ISM and the VLSI revolution for the country. And my task is made easier by the nice presentation by Hitesh ji, who spoke about AI at the edge. So maybe it helps us to synergize. So as we walk, as a country, we have a vision. And it is stated unequivocally multiple times by our Prime Minister. Many of the quotes are listed here. And what is not listed here, I will tell. Couple of months ago, we had a delegation from Australia who were working on what they call intelligent transport systems. And Bangalore is very, very famous for our traffic and its management. So as a delegation, we went and met the head of transport, responsible person, the DCP, Deputy Commissioner of Police Traffic in Bangalore. He had his first slide, which I thought in future I'll borrow from him with their permission and put it as my slide. He said Bangalore traffic was, he told 3 reasons, top 3 reasons why Bangalore is so congested. One of the reasons he put out of the top 3 is the number of semiconductor startups in Bangalore that is coming through. He said, because of being needed to be polite, he said, I cannot call it mushrooming of semiconductor startups in Bangalore. He said, that is what is one of the major reasons for the traffic jam. So I think India is in the right direction. I have not put that slide here, but it gives you a hint of where we are poised to. And it makes sense, more so with the current turmoil, both with respect to oil as well as other things, we look at it. So at a higher level, maybe being a keynote address, I think these 3, I will say the key points. The rest will be how we are planning to do it, achieve it in the longer term. If you read the first point, India has grown thanks to the Y2K, which is started, gave us a flip to become a global ITES and IT superpower. And that resulted in, again, Ministry of Electronics and IT started the first PGDCA MCA program on pilot, which was later adopted by UGC, AICT, and other institutions. And that has taken us for last 30 years, 3 decades. Indian IT superpower started with that seed that was done in late 80s, the DOE, ACC, and other things, and the MCA trial, PGDC, and so on. So, yesterday we all heard the latest release of ChatGPT. And one of the statements in the interview, if you read, talks about how no program needed to be written today. Everything will be done out of the box. It will use either existing legally approved open source or public code, and it will give the complete solution of your algorithm, whatever problem you define. If you read in between line, that is what it says. Indirectly saying, there is no need for any regular, traditional, old programmers going forward, if his claims are true and we trust it and so on. But it gives a very strong message that as we go away from ITES, what is our next destination to retain the leadership? Like vehicles, we are talking about EV. Energy, we are talking about renewables. So what do we do? So from ITES, now if you look forward, there are many reasons, but I'll highlight 3 points that will keep us continue to be the leader in service, for which actions are being taken. One of them is realizing that what we are already doing, the fabless chip design. EDA companies are the companies that use EDA tools for fabless design. So that will still be service industry. That will keep the leadership up. But that is not enough. Nations build on their products and solutions. So we have to move from fabless design to the complete package. That is the third part, from fabless to the final solution, which can be a product, which has an application, which can be a subsystem, submodule, ASIC that can be plugged in, which means by extending our EDA expertise, semiconductor chip design expertise, which has again been nurtured through informal channels, including our VLSI Society of India, who have done a long service. That is the reason when Dr. Satya spoke, he talked about that one-tops program. Unless you actually realize a silicon, unless it is actually tested and put into a system as a product or a component of the product, we cannot go forward. The moment we do that, the ambition of the country to add a product as another pillar, service nation plus product nation, which means we are looking at keeping the leadership in service, at the same time adding product as another vertical, major pillar. Without that, it will be very difficult to sustain the amazing, fastest growing economy tag. The dream of breaching the top 3 countries in the world, digital economies, etc. So this is very much needed. And to do both, the other aspect, that is what Mr. Hitesh talked about, is we are using AI everywhere today, either knowingly or unknowingly. It has creeped into our systems everywhere. So the question of trustworthy AI, ethical AI, comprehensible AI, there are many terms that are used. But to do that, if you all know, all of you may agree, if not full, at least in part, the entire AI system, the success depends on not on anything else in the end use. The end use of AI is, one of the major end use is inferencing. We use it as an inferencing engine. So the inferences are based on how do you train the system. Now to train the system, you have to give inputs. If the inputs are biased or low fidelity in nature, your inference is going to be wrong. So if that is the case, what do we need? We need sensors that are trustworthy, which can feed, because sensors are the eyes and ears of the training system. All your smart system give input. You take Mohali, Chandigarh, there are cameras everywhere. And I am told there are certain places, challan will come online when you use that particular lane. But online itself, if you give a proof, there was an emergency or I was going to an hospital, then the challan is waived off based on the context. I am very happy to note that such a thing is happening here. It's a challenge in many other cities. So Chandigarh is amazing and leading in that. But the fact is, now you trust the sensor. The CCTV sensors are so trustworthy, challan doesn't come to be at the wrong place and things like that, because in 2000, what time it was? Yeah, around 2004-5, there was a seminar by ISACA, one of the information security teams. They were talking about, that is when Delhi started finding zero tolerance zones in those days. People will come with pictures saying that number plate is of a two-wheeler, I drive a four-wheeler. That was the quality of the CCTV. So people were mocking. End of the day, what it means, unless your input data, the sensors, the sensing elements are of high quality, trustworthy, things will not move. Even for service, even for products. And where do you get high quality, high fidelity sensors? Unless you have chip designers who will design chips and build applications and IPRs on top of it. So this conference is essentially deciding whether India will succeed or not. VLSI design and testing. If you do it right, the country's future, at least for the next 25-30 years, with the anticipated growth, maybe we can even surpass. So I think that is the premise. The rest are all kind of, how are we planning so that if there are improvements possible, collaboration opportunities, we work together to achieve the goal. So from that perspective, now anytime last 2 minutes, I will be able to summarize also. So once again, so with that background, I will go back. So chip-in was also mentioned by Dr. Satya Gupta in his presentation. And many of the institutes here are actually part of that, and even companies. either as a service provider, for example, Renesas, who is going to speak right after me, they are one of the key partners in our chip-in journey. How do we make India a VLSI superpower going forward? So if you look at it, we started in 2021 when under ISM, India Semiconductor Mission, the design linked incentive for MSME and others were announced, and academic G2S was announced, chip to startup. In the last 4 years, a lot of water has flown, and part of it because we had some amazing volunteers who put nation first agenda irrespective of their affiliation to the companies. We had various technical committees, evaluation committees. Many of the members are here who have helped us achieve that goal. So today, if you look at it, in addition to what all we have, the numbers will come. But from pure so-called netlist or GDS2 generation, we have moved on today by providing an emulation platform for startups available. And then we are already starting on ultra-low temperature design. And going forward, the right on top is what we just mentioned, the one-tops program. In fact, this is a revolution by itself. Typically, when somebody comes for a chip design, we start with 36 months to 60 months kind of timeline from design to a actually usable chip or ASIC that will hit the market, depending on the complexity and the functionalities and testing. Now we are trying to break that to 18 months, which is an unbelievable reduction in time. And amazingly, a number of initiatives in that line has been taken. Many of the institutes who have already received the details of one-tops know about it. Others will, if we have not reached, will reach out. So very specific scheme has been made so that in 18 months, we are able to actually siliconize a design from concept to at least the first round of silicon. So that is one initiative. We will see it going. Then you'll find today world is talking about quantum. And last 30 years, the world is working on superconductivity as superconductivity itself. We are working hard. If you look at all of them are cryogenic. Even many of you who travel abroad or otherwise, for example, if you ever go to certain yellow fever zone countries, you have to take a shot. You talk to the hospital, they say if I open a box, it is kept in a very, very cool temperature, some extremely low temperature. And if they open, the entire bundle has to be used. They say unless this many people come for shots, we will not be giving an appointment. Otherwise, this many doses will go waste. So it is time from all purposes, all domains, that India goes beyond traditional design to cryogenic design as well. So that is the effort which will allow us to look into superconductivity, quantum QPU design beyond CPU, GPU. So that is the enablement that we'll be doing in the next year. And we'll also doing the post-silicon, whatever we need to do, the testing and other things, post-MPW, shuttles and so on. They all will be coming in place in the next 1 year. By 27, today, India, we do not have an Indian value chain aggregator. We use lot of services. There is nothing wrong in using it, but the VCA actually is the one which converts the paper design into final usable silicon with various processes. And they also need to understand the requirements of the fab, whether it is TSMC, UMC, PMC, PSMC, Global Foundries, you name it, or Samsung, Intel, does not matter. Even SCL that we work with closely. Unless you have a direct access to them, you understand the process, get the PDKs, what are the fab compliance checks, because that will decide your quality of outcome, how many shuttles, respins you need to get the chip out, or whether the yield percentage will be good or bad, how does the substrate impact? You choose a 8-inch wafer, 12-inch wafer, whatever that it is, silicon wafer, optical wafer, all those things. This knowledge of the process by which a chip is realized versus what is simulated on paper, that gap will be completely closed when you actually become a VC and fab compliance check. So that will help us to do a better quality design right from beginning. And we'll be able to support multiple nodes as we go forward beyond what we do. So that is something we are talking to do it in the next 2 years. And going further, we'll also getting into photonics, because that is another area, silicon photonics and photonics needed for communication big time. And also to reduce the time delay between node-to-node communication, server-to-server communication, because today, whatever happens in the silicon, to convert into optical, there is a lot of hardware involved. There is other than power, silicon, real estate on the board, all of them become very important. So if everything can be done in optical domain directly, there is nothing like it. So photonic is another area. Many people call it PIC, photonic integrated circuits also. So that is another area we'll be building our capability on. So the roadmap is in line with what we want to achieve as a country to develop products. And this slide should have been ideally presented by Meiti, but just I'm flashing it here. So if you look at it, the market share, what is projected is what is visible. But with our experience, we can tell you that the projected numbers are normally tip of the iceberg. Because many people are hoping that it will come. But the moment somebody sees even a hint of confirmation that it is really happening, you will suddenly see that number is expanding 10x, 20x. So that is what happens in India. So these are in a conservative way, but it will grow much more. And given the current global reality, we expect another acceleration because of those geopolitical situations. And just in terms of number, all of you know it was a $10 billion commitment from Government of India, and we have multiple things, including talent development, and that is where we are all part of the journey. And the chip in at Bangalore, CDAC, we do all the tech support. For the DLI, in terms of funds, our Noida has a PMU, Project Management Unit, who will take care of the other aspects of progress and things like that. The idea is, I think, we are not world #1 just because we have all EDA tools under one roof, but because this one supports from entry-level academia, basic introduction to VLSI kind of course, all the way up to high-end, even a sub-10 nanometer design. So all kind of tool chains, that kind of expertise is there to handhold people, and we know exactly which simulator or which tool works better for a given application and given talent pool. So this integrated thing is what is making the whole thing very unique. And as I speak, it is not surprising that many countries are requesting us to replicate in their countries. So this is really, what should I say, the recognition that we have been able to achieve because of this collaboration and consolidation across all the people involved in the ecosystem. So what we do is we provide not just EDA tool support, we give access to IP core repository for the foundries PDK support, then prototyping support, post-silicon and so on. Just for the numbers, 285 plus academic institutes are already under that. While it may look like what is this number all about, nothing great. The program started with a target of 120 institutions. And what was supposed to 120, we are already 285, and another 50 are in queue. And we have been so lucky that the tool vendors, suppliers, they have graciously extended their support to additional licenses for academia without changing any costing model. So that means it has become kind of truly democratized. Earlier, VLSI tool access, institutes cannot introduce a course because to negotiate and get a tool takes 2 to 3 years. Today, it is out of the box. So this is a complete change. So somebody mentioned Mr. Charan Gurumurthy want 1 lakh people. If you want, all we need is one academic calendar to get the basic manpower ready. So we have reached that kind of scalable infrastructure in the country we should be proud of. And when we started, again, just to say, when I mentioned our projections are very conservative, I will confirm with the second part, which says 75 chip design projects from 72 startups. When the scheme was announced, first 1 to 1.5 years, we could, with lot of difficulty, find 2 startups and MSMEs which can be funded. Only 2. The target was 100 in 5 years. That was the number. When we did 2, and though today I am standing and smiling, at the end of first year, you should have seen my fate in that room along with my colleagues who are here. They are also now smiling. I have Vivian, Anis, Pranos, and Rajshekhar and all. We were kind of bulldozed. 2 out of 100. How will you achieve 100 in 5 years? It looked like, are we realistic in our ISM targets? But what it took was, the very first year, there was no previous experience. So startup, MSME, the process, the government, the procedures, everyone is trying to understand what will happen, what will not happen. And there is always the skepticism about when will the funds come. Getting approval is one part, will I really see the money? Because I'm going to invest hoping that I'll get a reimbursement. If I don't get it on time, what will happen? Because it's all a high risk, and for a startup, every day, living by the minute nowadays, not even by the day, because they have to pay. This is a top talent industry, high cost. So, but at the end of 1 year, when the 2 companies actually received their funds on time, next 18 months, 2 became already 70 plus. So in 2 years, we achieved 70% of the target, and we still have 2 years to go. And as I speak, the scheme is undergoing revision and is temporarily suspended. Otherwise, I believe we have to cross the 100 by now. So this is the way the India scales. So we should keep in mind whatever number is shown, if we do it right, we will beat it hands down. So let's hope it happens, and we'll do whatever we could to reach that thing. And when I say collaborators, these are not 1 or 2. As you can see, a large number of people, and 2 of them are going to speak right after me, Renesas and Open Power. Both are right here. So you'll also hear from them how they are supporting the ecosystem in India to grow. And we are all partners, happily traveling together. And in addition to what we generally do as a support, the first time we did the C2S equivalent program, it was called the C2SD, we realized 71 chips in 5 years. Second version, we are into 2 years, already 100 designs are out of which 34 are already done, another 22 are under fabrication, right at SEL, the place where we are discussing. So you are actually changing the ecosystem by providing that kind of support from SEL. I wish Kamaljit Singh was here to hear this, because getting honored in your own hometown is something. Actually, SEL, for whatever people say, they have done an amazing job here to tape out this many. And now we are talking about any design given, SEL is going to promise to do it in 3 months' time. So that is the kind of change, the speed that we have brought out in our own Indian ecosystem. So this is going to change. And we have also distributed various FPGA boards and all. And when we did the design hackathon, many of the judges, including Chitra Madam and Satya Sir, who are all here, I think Kala Madam was also mentor. See, I saw her, many of you. Thank you. So all of them are here. They were surprised and amazed that when we announced a hackathon with problem statement, analog and digital, 10,000, close to 10,000 students, 2,000 plus teams applied. And we had to do 3 rounds of filtering to get the top 40. And when they came for 100 hours, this was the first time, I think, a 100-hour physical hackathon happened. Normally it is 72 hours, 48 hours. Beyond that, sustenance is very difficult. VLSI is very different. So we made it 100 hours. And believe me, that 100 hours, probably everyone slept 3 hours per day, and the teams worked day and night. But the beauty was, the supporting team, the industry side, they gave pre-training, they gave boards to them, and their teams are also co-located for 100 hours. They did not leave the venue throughout in Bangalore. So that was the commitment that country has shown to everyone that yes, we can achieve things. And the winners were not just from top IITs, but there were institutes that were not, they were from private institutes, and some of them are not that popular in public domain. But you could see, there were second-year students who won a prize, who are just entering into VLSI course. So they learnt on their own, and still they were on the top. The kind of talent India has, the kind of enthusiasm and ability to learn has been amazing. So these are things to see. So we are very confident the numbers and all will be achieved. So in the interest of time, maybe I'll quickly go through. So whatever I said, there is details shown here, just what are the outcomes we have done. These are the previous tape outs that we did. And interestingly, these things are happening not through just the optics and announcements and buying a tools and setting an infrastructure. There is a continuous handholding that is happening. You can see amazingly, in one single year, there are 200 training sessions totaling 800 plus days. So any given day, 2 to 3 trainings are happening, either online or physical. And all these things are also available on their, on our channel. So it is a recorded thing. So we are building onto an ecosystem of so much of training and learning materials. Today, if you want to start a VLSI course, basically you need only a VLSI coordinator, course coordinator. You don't need even a single faculty. The entire thing is available online, and the team will be able to support, backend. So that is where we stand. When we say chip in and all, many of the times, the invited speaker could be Satya Gupta and all. So just we take credit because we invited them under our logo. But there are a lot of things that is happening. And fiscal support I mentioned. So it is not only you design chip. If it gets into a product and you are able to sell, whatever the sales volume, no questions asked, you can see that 4 to 6% you will get a top-up incentive. So your profit margin simply goes up by 5% at the end of the year. So these are kind of things that is changing the landscape, and there is no need to do theoretical design anymore. You better do a product. And of course, there are more details for the number. And this is the emulation platform I was talking about. Just before concluding, 2 slides on what else we do, because while we have a CDAC Mohali, I have a team here from Balvinder, and the whole team is here. We are locally present here as well. And we have Param Utkars, which is a supercomputer in Bangalore, HPC system. But we are currently building a 30 petaflop supercomputing, India's largest, in Bangalore. And that is completely designed in India, manufactured in India. So one can be proud of it. And Chandigarh is also capital of Haryana. So I can say that one of the production partner is VDAT, which is from Gurgaon and Manesar. So Haryana is again part of the journey that is happening. And on quantum, we do lots and lots of things. We are part of various quantum missions. And then in addition to doing the EDA support for the academics and DLI, CDAC itself is developing a complete ecosystem so that India becomes Atmanirbhar and sovereign as we go forward. And I think going forward, we have everything in place to make India a proud design, made in India, made for the world, that tagline that we are talking about. And I'm very confident that we'll give the best smart systems, smart sensors, which will enable our AI ecosystem. We'll give the best chips to the world, and we will become the trusted partner. And in this journey, as CDAC as a whole, and chip in particular for this particular context, we invite all of you to please come collaborate with us. And interestingly, this year, based on the work that we have done, there is a Supercomputing India conference coming in December 2nd week to Bangalore. This will be the inaugural edition. So far it has happens only in US, Europe and Asian edition. So now we have got an India edition ready. So please be part of it. and we hope to see you working with each other all the time. Thank you so much. Thanks for your time.
Well, thank you, Dr. Sudarshan, for sharing such a thought-provoking address. Your insights have truly enriched today's discussions. Very captivating slides, sir, and presentation. Next on, I now invite Chitra ma'am, Secretary, VLSI Society of India, to speak a few words on product mission.
I just wanted to take a moment just to make you all understand that this is just not talking and not in the PowerPoint because CDAC is our partner and then whatever Sudarshans are mentioned. So these are the design kits that you're all seeing. This is called Quick Connect Design Kits. You will be able to realize multiple products with these kits. Some of the IoT applications or anything that you can dream of, some of the drone flight controller. My friend Sarita is here. I mean, this could go inside that. Point is, students over here and then educators make use of these kits. These are all available for all the C2S colleges and the Altium PCB design solutions also. These will be getting to your students' hands and they will be able to make innovative products and build wonders. That's all I wanted to say. So thank you so much, CDAC, in enabling us as Renaissance here. Thank you, Sudarshan, sir. Please come over to stage, your memento. Satya, can I welcome you?
So Satya sir, please present a token of gratitude to Dr. Sudarshan. Thank you, sir. Moving on, we are joined by Dr. Gaurav Goel today. Dr. Gaurav Goel, Senior Principal Engineer with Renesas Electronics, is an expert in memory, I/O, and systems. Over the course of 22 plus years of industry experience, he has architected, designed, and deployed memory solutions across multiple semiconductor companies such as Intel, AMD, Analog Devices, and Renesas, ranging from DDR, LPDDR, GDDR technologies, and high-speed serial I/O products such as SATA and PCI. He holds several patents in these areas. He completed bachelor's in engineering from NIT Trichy, top of the class. He has been associated with industry academia initiatives and was the tutorial chair for VLSID 2025 in Bangalore. Now, I invite Dr. Gaurav Goel, Senior Principal Engineer at Renaissance, to deliver his invited address. With extensive expertise in semiconductor design and innovation, Dr. Goel brings valuable industry insights that bridge technology and real-world applications. Over to you, sir.
Thank you for that generous introduction. So I have just one correction to make. I'm yet to complete my PhD. Or I'm not a PhD. Okay, so good afternoon, everyone. I'm happy to be back in Chandigarh. So one thing which I did not include in my introduction was that Chandigarh and I go back way back. I was born in Chandigarh, so I am a Chandigarh boy from that perspective. Okay, and I also studied here for a little while, and it is great to be back here and see that silicon design or the VLSI ecosystem is taking shape here. Thank you so much. Okay, so let's start with some fun. Can somebody, without Googling of course, can somebody tell me how much memory was required to put the first man on moon through the Apollo 11 guidance computer system? Any guesses? Of the order of magnitude will also do. It was 4 KB, just 4 KB of RAM. The phone I use uses 8 GB of RAM these days, and we tend to complain, oh, the reels are loading slowly. So as much as compute has gone up, so has been the demand for memory. Compute and memory go hand in hand. There cannot be compute without memory. If I refer to today's discussions, so some of the earlier speakers and panelists talked about how we are now being constrained by lack of memory. So I have a term for it, or rather not just me, everybody in the industry, which is called the memory wall. What exactly is it? So if you look at this, do we have a pointer? Laser pointer? Okay. So I don't think there is anybody in this room who has not used any kind of a AI engine. I'm sure everybody has used for personal and professional purposes, ChatGPT, Gemini, and everything, right? And what we have seen in the last few days is an exponential growth. If you look at the chart on the left side, there is an exponential growth in terms of the LLM models. They are growing very, very fast. But all compute requires memory. So, as I said, all compute requires memory. And while our compute growth in AI has been exponential, that has not been the case for hardware. So if you see the hardware growth in terms of the DRAM technology, in terms of the bandwidth interface technology, it is linear. So what does it mean? What it means is that we are moving from an era which was compute limited to a memory bandwidth limited era. It is not great news, but it's also a very interesting, challenging technical problem to solve. So what I've highlighted here is the memory wall, which indicates that how much is the gap between the exponential and the exponential growth of software versus the linear growth of hardware associated with AI. And that is a big problem. Earlier, Sharon spoke about it, Ravi Mahajan from Intel, Wilfred Gomes talked about it. So we are getting limited by memory. And it is not, so if you think about it, at the end of the day, what does an AI engine do? It moves data. It moves data from memory to compute engines, back to memory, and it does it several times. So because it is moving data, it also consumes energy. And it consumes huge amount of energy. So much so that I think last year, Google and Meta had submitted an application to build small-scale nuclear power plant, because now the data centers are getting are consuming too much power. In fact, in some smaller cities in US, the local governments are limiting the amount of electricity being provided to data centers. So there are twofold problems. We don't have enough memory, and our transactions, the memory transactions, are consuming too much power. Okay? So let's understand a little bit about what does a modern data center that also supports AI, what does it look like? What are the different components here? So of course, the server class CPUs are of course there, and but we also have the GPUs these days, of course, because of the AI content. And the CPU uses a different type of memory from GPU. So CPU still uses DRAM, which was the oldest type of DRAMs that are used. Now I want to, so since some students are here, I want to explain to them how different memories are. So if you see what is shown on your top left is in the center is the CPU, and you see these green cards around, that is your memory. Now, at the bottom, what we have is a new type of memory, which is called the MRDIMM, but we also have the DDR DRAM. So this is what is used. Now, you might ask, why do we have it like cards? Because we need dynamic capacity increase, we need serviceability, right? And we want better thermals, so we can space the cards apart so that we can have proper heat sinks. This is how traditional servers were, and we were good enough. But now, with the introduction of GPU, that is not good enough. You need more memory, you need it closer to GPUs. So traditionally, GPUs, when they were largely used for graphics and even cryptocurrency mining, so we had GPU sitting in the center, and it was combined, it was flanked by GDDR. So if you look on the right side top, so that is how you can see in the orange boxes, the GDDR memory is all around the CPU. The idea was to bring it closer, and also GDDR used to consume more power, but at that time, the use case was different. When we moved to the AI era, what we realized is that even that is not sufficient. We need even more memory. So we went to HBM, so HBM is very different from all the other memories that are used in data centers. So HBM undergoes what is known as, it's a 2.5D packaging. What it means is that you have in the center you have the GPU, and then you have these vertical memory stacks, and they're all connected to the CPU on the same package. So when you look at it, you just see one black box. But if you open up that box, you will see CPU and multiple stacks of vertical memory around it. So that is how it is. Now, why is it like this? So let's talk about a little more in detail. So like I said, DDR is the data center memory, has been there for ages. I have been working on it for 15 plus years. What makes it so good? What makes it good is that it is cheap, it's easy to scale up, provides good cost, and has good amount of RAS features. Now, what are these RAS features and why are they important? In servers, you have multiple racks stacked in closed spaces. The thermals are poor, the heat dissipation is not that great. Chances of errors, soft errors, are high. Now, in that case, you want to be able to service them. If a card has gone bad, you must be able to swap it out, right? So if you see on the picture on the right-hand side, you can see one DIMM or the data card. It is very easy to replace. So it provides great RAS features. But that is not good enough for AI, because what is most important for AI is to have bandwidth. DDR was great at lower latency. Now these two are very different things. Latency means I want data fast. Bandwidth means I need more data. I can compromise a little bit on latency, but I need more data together. So that is when GDDR was used for graphics earlier. Now, but even that is not good enough for AI. So what we use for AI is HBM these days. Now, however, there are two aspects in AI servers. You have training, and then you have inference. And like I mentioned, you have CPU and GPU working together, because CPU still needs to do some pre and post processing. So that work is still done by CPU. And what kind of memory does CPU use? DDR. So that is why the DDR memory will continue to be used in server data centers. Now, what is the issue that we are facing is that the DDR technology takes a long time to evolve. So if you look at the chart that I put together, it shows the evolution of DDR over the years. It started in 2000 with DDR1, which was 266 megahertz, to DDR5, which will top out at 8400. That's great progress, but if you see the gap between DDR3 to DDR4 or DDR4 to DDR5, we are taking 6-7 years for the next generation of protocol to come. But AI is not waiting for that. We need more memory, and yesterday. So how do we get it? So there is a new form factor of devices, memory devices, which are coming, And they are called, Renesas is one of the leaders in that, and it is called MRDIMM, multiplexed rank DIMM. What it means is that we take the data from multiple memories together, we put a specific chip for it, which we design at Renesas, and we crunch it together and send the data to host processor. What it does is that the memories don't need to work at higher speed, but the CPU will get the data at twice the speed. So that's the beauty of this technology. So DDR5 theoretically will top out at 8400 megabits per second, which means with these MRDIMM chips, you can possibly go up to 17.6 Gbps, theoretically speaking. We are at 12.8 today. So now let's talk about the other memory types. So in AI, I told you, so GDDR, which was earlier developed for graphics, we later found that, oh, they are great for Bitcoin mining, cryptocurrency mining. And then later, it was found that the parallel architecture of GPU is great for AI as well. So that is what we started with, but then again, the bandwidth was not enough. So we moved to HBM. Now, what is HBM? Like I mentioned, in HBM, on the same die, sorry, on the same package, you have multiple dies. It's a heterogeneous packaging, 2.5D. So here you can see we have the main compute die, the black one at the center, and then it is surrounded by multiple vertical stacks of memory. So if you see the image, here you can see the blue dies which are stacked together. These are the HBM stacks. And these stacks can be as high as 8 stacks and even 16 stacks. How does HBM really help? HBM has a very wide parallel bus. So much so, you can have 1,000 IOs running together. And that is in HBM3. The new HBM4 will have 2,000 IOs running together. So you can imagine the bandwidth, the sheer raw bandwidth that HBM will provide. Okay? That is why for all newest AI training, you use only HBM. But it is super expensive because as you can see, the packaging is technically very difficult. In fact, a little earlier when the geopolitical tension was there, so there were chips getting manufactured, the GPUs, dies getting manufactured in Taiwan, but they were not getting packaged and people were just waiting for them. So, so HBM is great for bandwidth, but not so great for cost. And there are a few other problems that I'll discuss. So this is the summary. Latency-wise, these days, because HBM is literally sitting there, is the greatest one. In terms of capacity, not that great. In terms of cost, not so good. And in terms of serviceability. Now so earlier, when there was a bad memory card, you could easily swap it out. Now what do? It is sitting on the same package. You can't replace it. So it's not great for RAS capabilities. So the question is, if memory is the villain, it is holding back our progress. Why don't memories evolve faster? Are the memory designers lethargic? That's not the answer. So let's understand what are the challenges. So if you look at the DRAM, each DRAM cell here, you can see is made up of one capacitor and one transistor. So the capacitor stores the charge and your transistor acts as the enable line for it. And then they are packed together to form an array, right? Now, as the technology node advances, they have to be packed together. And these capacitors are not ordinary capacitors. They are typically trench capacitors, which are very deep, right? Because they need to hold this charge longer. Otherwise, we have to keep refreshing it. So they have to be packed together and together. And with lower geometries, it becomes very hard to make such deep capacitors. So that is one problem. Secondly, in this array, now we want more capacity. So we want to pack in more and more things together, which increases the capacitance of the wrong thing, of the bit line, which will reduce the speed at which you can operate, which is a problem. So the third problem is the leakage current increases, which is again not desirable. So these are the manufacturing challenges that we have. So as you all know, logic foundries process nodes are different from DRAM ones. So we can talk about a 3 nanometer, 2 nanometer transistor for logic. You can't say the same for DRAMs. So the DRAMs are still manufactured. They have their own processes, but around 10 to 12 nanometers. We cannot compare them with the logic nodes. The second challenge is, and a fairly high challenge, is signal integrity at system level. We are talking of high-speed interfaces. Now, in these high-speed interfaces, these are parallel interfaces, so they suffer from EMI, crosstalk, noise, so that makes it very hard. Now, HBM4 is supposed to be 2000 bits wide channel. Now imagine the crosstalk it will have. So these are the challenges. We are reducing the voltage at which these interfaces are operating. So DDR5 is at 1.1 volt, DDR3 was at 1.5. It is great for increasing speed, but guess what? Your SNR reduces drastically, right? So, and in fact, now in GDDR7, for example, we are moving from NRZ signaling to PAM3 signaling to reduce the baud rate so that the inter-symbol interference and the channel insertion loss is less. But what happens is that your SNR reduces further, which means these circuits, receivers, are harder to design. And that is why you see that the growth in memory has been linear compared to compute. Okay? So I don't know how many of you had developed your own Ghibli images when Ghibli art first came. It became such a craze that Sam Altman had tweeted that, please stop doing that. Our GPUs are melting. So I want to explain this GPUs are melting concept. So as I said, we use 2.5D stacking. So you have a GPU on one side, and then you have HBM stack on the other side. Now the heat sink, poor heat sink, what will it do? There is too much of heating that is happening. So a lot of challenges are coming from heating, because in HBM, you are stacking up memories without providing enough thermal dissipation capacity. In fact, in some data centers, they are also considering liquid cooling. So this is from one such proposal where they're planning to use liquid cooling, and air cooling is no longer sufficient for that. This other challenge that we face is errors. Okay, great, you have manufactured memory, but is it reliable? We face two types of errors with memory: the hard errors and the soft errors. Hard errors come from manufacturing, as I told you the issues. And so typically you provide these redundant rows so that you can work with it. But soft errors happen in field. So I want to tell you a story about a funny incident about soft errors. Between 2009 and 2011, Toyota had to recall almost 9 million cars worldwide. And the problem was that there were some acceleration issues, this, that. They successfully argued in court that it has been happening because of soft errors happening in their code, which is stored in a memory, due to cosmic rays. So aging, heat, noise, radiation, all of these can cause soft errors, which happen on the field. You cannot predict. So what do? You need to be resilient as a system. We also face specific attacks in the field on memories. Rowhammer is a classic example where, if you look at this image, what the hackers do is that you will target the rows above and the below, specifically with certain pattern repeatedly, and that will introduce bit flips in the between layer. What happens as that? Corruption happens. So you need to be resilient of these kind of issues. So what has been traditionally done for mitigation of these errors is that you add ECC RAM. So instead, so if you look at the bottom green picture, you have 8 DRAMs. Okay. Now what we do for ECC is that we add another DRAM, we compute an error correcting code for the data that we are storing, and we store it along with data in the extra DRAM. So the SoC will compute it, store it, and when it reads both the data and ECC together, compares it, and then says, okay, now it is reliable, I can use it, otherwise I will not use it. This is one example. But as you can see, it's a wastage of resources. And this only provides 2 error detection and 1 single error correction mechanism, which is not, again, enough. And with the sizes decreasing and with certain kinds of memories, we are now exploring other variants, such as link ECC, where you have a dedicated pin on which these ECC will be sent and stored on the same die. In DDR5, they increased the data burst size, and they computed CRC to identify if there were transmission errors happening. So the bottom line is that memories will continue to face a lot of challenges in the field, from soft errors, from transmission errors, and we need resilient structures. They are not so straightforward to exponentially increase. So what are the future trends that we are seeing in data centers? So of course, the mixed usage of DRAM types will continue. You will see a mixture of DDR, HBM, GDDR, which will happen, but you will also very soon see a new entrant. Low power DDR or LPDDR was primarily designed for mobile applications. In most of your phones, that is what you will see, and also some lightweight laptops. Why is that important? Because again, mobile underwent a revolution faster than standard desktops and laptops. And so the LPDDR is evolving faster. It operates at a lower voltage, so its power dissipation is lower. Because of all these reasons, now even servers have started considering LPDDR for these operations. But LPDDR does not have the same RAS capability, serviceability, which DDR devices have. But nevertheless, very soon you will see LPDDR getting used in data centers. Meanwhile, you will still continue to see newer form factors, such as the multiplex rank DIMM, which I mentioned Renesas is working on, where you fetch data or write data from multiple memories, compress it, and send it to the host. These kind of novel solutions will be there because we still have a data crunch. So the bottom line is AI is great. It is creating a lot of new use cases for technology, but it is putting a lot of pressure on memory. And as the researchers, students, academia folks present here, I would suggest you to also start looking at memory as the limiting factor for AI and what can be done to improve in terms of bandwidth, power, and reliability. Thank you.
So let's break the memory wall with this. Thank you, Mr. Gaurav Goyal. I hope I am correct now, for sharing your deep expertise and industry perspectives with us today. Your insights into memory technologies and high-speed I/O have added great value to this symposium. Thank you so much. I now request Dr. Satya Gupta and Chitra ma'am to present a memento as a token of gratitude to Mr. Gaurav Goyal. Thank you. Well, we are pleased to have Mr. Ganeshan Narayana Swamy with us. Mr. Ganeshan is president of the Open Power Foundation worldwide and a veteran in AI, HPC, and chip design. He has over 30 years of experience, including leadership roles at IBM, driving open power initiatives. He has built global academic programs and hands-on labs for chip design and high-performance computing. An award-winning educator, he has delivered impactful training across universities and industry. Sir now leads AI solutions at a stealth startup, bridging academia and industry through innovation. I now invite Mr. Ganeshan for his talk, please. Over to you, sir.
Good afternoon to all. Thank you very much for inviting me to be part of this conference or symposium, whatever the title here. With the experience, whatever I have, for the last 30 years, from the chip to startup, from CDAC initiative locally and globally, I have done, I think, presentations in 40 countries all over, probably the world, many countries I traveled. And in US, there are 50 states where, at least 30 states, I initiated many programs and workshops around this, the open power technology, which I am going to be sharing with you in the next few minutes. With that, I just want to tell you, there are a lot of people really talked about chip and the systems and, the memory and all the stuff. But what is that I want to see in India? Around 30 states. I know that, 30 states. Nearly this trip, as part of last 1 month, I have traveled across 10 states here, and I've been running, a lot of programs and, workshops and, the educational sections across India. And what I have seen, there are a lot of theoretical knowledge, people gathering, but practically people, not putting effort. And that is what I want, I want to see and I want to enable. And, that is where, I am actually jumping in here. I know in the middle of, the lunchtime I'm doing this, but this is going to be a good learning before lunch. And also opportunity for people to, collaborate with the open innovation. That is what I am going to bring here. What happened here? How many of you know, the IBM has built a chip, with the 2 nanometer? Nobody knows. That's what IBM brings in. There are a lot of good technologies, behind the scene IBM is doing. Not many people know about that. And this was a chip. I was part of IBM, and also I was leading, the open power innovation. IBM built in 2017 and 18 timeframe as part of supercomputer. The 2 supercomputers which we built to do a lot of, the research in medical as well as many other areas too. So, any issues? Still they are troubleshooting, I have given my slide deck to them, to present. It's not my laptop though. Anyway, so this is a chip, which we built, in 2017 as part of supercomputer vision. And what do you think, how many nanometer the chip would have been? How many nanometer? 7? Yeah. Thank you for answering that, but that's not the right answer. 2017, 2018 time frame. 14 nanometer. So this was built using, the IBM, the Power ISA architecture, instruction set architecture, which we open sourced in, around the time, as part of supercomputing building. Okay, let me go through that. So this is a chip, runs with, 200 applications, parallel applications in high performance computing area. Definitely, you would know about that. And also, this was a chip, connected with NVIDIA V100 GPU during that time. NVIDIA was one of the, the partners with us, and we built, jointly, the chip as well as the NVIDIA V100 GPU to collaborate with the U.S. government, to get into this kind of, the supercomputing mission. That was actually giving like nearly 200 petaflop of, the supercomputing power. And I think, I'm sure like, some of the Indian institutes also had access to that kind of a supercomputer during those days. And that was a, kind of, the super powerful things, which we did in, I think 8 years back, as part of, the foundation which I'm leading right now as a president. Okay. Interest of timing, I will continue that. So the Open Power Foundation is a non-profit organization which runs across 200 countries. Wherever IBM Power chip has been installed and has been running with the companies, with the enterprises, we have been, running this, like a foundation, and this has been like nearly 13 years of, journey where there are like 200, there are like 200 plus, the global partners we have who have been, collaborating with us and, doing all kinds of, innovation from the chip systems and, software. All those stuff, we can do with the open power stack, whatever we open sourced. This has been there like, when you have like, instruction set architecture, from us, like you can start building your own code too, build your own device. I know that, the previous speakers, Mr. Sudarshan as well as NXP director also presented about, the AI and edge. But with this technology, whatever I'm talking about here, you can immediately start building your own device. You can immediately start devising, this kind of a chip also you can build, because all the stuff, like whatever is needed to build a chip, we open sourced it. And also there are a lot of prototypes available. Many, partners have been building worldwide. And there are, use cases which I have, which I am going to go through it. And then, that's what I want to say here is ISA is an instruction set architecture which we open sourced, and silicon. There are like 3 silicons, powerful silicons which we open sourced. One is microwatt, a simple core, the RTL code, which we open sourced, and also the A20, A2Y core. These are the 2 cores were part of 2014 supercomputer. That also we open sourced. That also, like, you can get engaged, you can start building your own laptop or a desktop or whatever device you think. We can also help you out, There are people who are partnering with us, who have been, engaging with us and, and collaborating and, trying to develop devices using the RTL code, whatever we open sourced. And, the end goal for us is actually open innovation. That's where, we want to basically educate the people, go build your device and get the practical knowledge, not the theoretical knowledge only. When you go and, look at the code, RTL code, you will understand, the various features, into the code, like a various fetch instruction and, many other instructions, like even memory operation and, IO operations and all the stuff, is there in the code. Like a 25,000 lines of code, which we open source as part of Microwatt. Suddenly, there are a lot of, the videos available, thousands of videos available. Even we have been collaborating with the CDAC. Dr. Sudarshan has been supporting us, the vision, and he also traveled to US, and discussed with us, in various meetings. And there are many opportunities are there, to collaborate and innovate on our platform. And this is a slide where, we created in 2013, and many collaborators have been, working with us on this. Can you move on to the next slide? And you see here, this power processor, whatever IBM invented 30 years ago, when I joined IBM in 1996, I have been seeing the power processor with the Deep Blue's, the supercomputer. Since then, this has been there in the industry and, making a powerful, the enterprise innovations. And recently, IBM released a Power 11 based on the open ISA processor. And there are, the Power 11 has been, used by many banks worldwide. Nearly 2,000 banks in the world, have been using the, our Power 11 chip too. So if you want to know more about Power 11 chip, definitely, you can reach me out and we can set up a separate, one-on-one discussion also with that. Even we are also opening up, the a lab access through CDAC already offering that kind of a lab with the, the open source code, whatever I was talking about. And also University of Oregon, where we have a very good lab setup where people can go and explore, immediately, all these Power ISA and even EDA platform. The Open Road is a EDA platform, which we are actually working with the University of California, San Diego. And obviously, the microwatt and A2O core, all this stuff available. One can, work with us and, start collaborating and innovating, on our technologies too. And as you see here, the open, the ISA has got 16,000 instructions. I'm not, I'm sure, there are other commercial ISAs are available. Definitely, they may not have these many instructions because this has been there, more than 30 plus years. And, supporting the industries, worldwide, around, 200 countries. And that's a main reason, why, a lot of instructions have been developed and incorporated and heavily used to. Next slide, please. So why open source? Why the open source is very important these days. One is actually, definitely, you can do open innovation. The students, immediately can get access to the RTL code access and, the GDS2 flow kind of, the platform and everything. And, on the commercial thing, it's good to go. There are a lot of commercial companies are there, but you can't see the code there. But here, you can see, the internals of, even the chip, whatever we develop, the code. That is actually the advantage of it. You have to see the code and understand, what the code does. Even if it is a 25,000 lines code or 250K lines of code. But, you can, go through the code with a team and understand that and, go and, innovate on top of that. Or come out with, some kind of a new ideas on top of, the open innovative code. And with, along with that, there's another reason why this open source is going to create a new world. Currently, there are a lot of geopolitics, issues going on, and suddenly, every country wants to build their own chip. Why? Because of, the security risk. So in this, the open technology, you can build your secured system from chip to the solution. Everything, you can control. And, it's similar to, whatever you want to, go develop on your own stack. With knowledge in everywhere, like in ISA, in RTL code, in GDS2 flow, kind of EDA platform, and the software which runs on it. And the code, whatever we open source, along with that, we also attach the Linux on it, and people can boot the Linux, with the code, whatever we have. So that is the other advantage. Even, the Gen AI kind of application, you can immediately run on your own device. You can start with the FPGA and FPGA kind of a device, and later on, you can put it on a real chip and probably a platform, for you to go and start working on it. And that is the main thing. There is no limitations here. Like all other commercial entities, will have a lot of limitations. You can't do several things. For everything, you need to buy a license or acquire a license, or maybe the license will expire, after 1 year or 2 years. But here, 100%, completely open source, platform what we have. And supply chain. that is also another thing, critical thing. Sometimes, during COVID time, there are a lot of semiconductor supply chain challenge. That and all, we can avoid here by, doing your own device and your own time, you can produce your device too. And these are all the advantages, I would say. Certainly, there are several partners working with us and, adding more features to part of, our a strong, the platform, whatever we developed. Can you move on a second? And yeah, we talked about it, many, presenters already talked about it, but these are all the current use cases people are using, our platform. And as you see here, high performance computing, infrastructure, and then artificial intelligence. These are the places where, for training, for inferencing, for everything, this platform is being used. And the future use cases, and also currently also people are using it for 5G, 6G, kind of, the platform, and the automobile, and storage, and industrial IoT. All these places where, the platform is currently being used, and, many use cases have been, presented in many conferences too, as part of, my workshop, as well as, in the general, the IBM conferences too. So, the community, this is what actually very important too. This is actually not just me, running the show here. There are like a lot of people, behind the scene running the show, and this kind of opportunity for you to collaborate and contribute to this community is very important. And that's where, the community also will grow, and it will sustain momentum and future, future ready, kind of, the supercomputer also one can build with this kind of a platform. And that's where, it's all connected dots, the globally connected dots. And there are a lot of innovation went in. Maybe, you can spend some time on openpowerfoundation.org and take a look at it. And we do have a Slack channel, a free Slack channel where thousands of people are collaborating. Even today, there are 4 or 5 Slack channels are very active. In India, as well as in US and in Europe and in Saudi Arabia, which I have been, monitoring on that. And, all those, innovations, you can also see what people are doing, how they are collaborating, and all the stuff. You're all welcome to join, the Slack channel too. And certainly, the GitHub, the Git system is also available where you can see the code. If you look at, if you go and search in the Google or ChatGPT, Open Power, you will get all the details. Very, very quickly, within one second, you will get all the details, whatever we have. Because the ChatGPT got trained already with Open Power, ecosystem with the thousands of people. So, what I would say, this is a, kind of a platform where the whole India needs, because you can get a lot of practical experiences immediately after getting into this platform within a month time frame, and then you can start working with industries and government and work on developing a new device or an edge device or an inferencing device or a new GPU. Why not? There are companies who are working with us to develop a new GPU with our platform too. Next slide, please. So this is the stack I've been talking about here, what we open sourced, open IP, the open cores, the power cores, the IBM mostly, as part of that. And then Solid Silicon, another US-based company is working with us to build their own, CPU, based with the Power ISA based. And then the reference design, the motherboard reference design is also open source. You can take our, the reference design and start plugging this kind of a CPU, with that. Your own CPU also you can build. And with that, and, and start making your own, the edge device or any kind of, the laptop or any other form factor, servers or, the desktop devices. And then open firmware, that is also open source. So the complete stack we have here, end to end, that's what I would say here. And then the Linux SDKs, there are a lot of SDKs, there. There are certain companies are already collaborating and adding more features to it too. And then we created, several apps, and the specific apps where already I mentioned about it. The University of Oregon is one of them. Oregon State University is also another one. MIT Boston also, I'm working with them closely and see what else we can do, on this open, innovative platform. Next slide, please. So the microwatt, whatever I mentioned, these are all the features. I don't want to, I'm not going to go through that, but if you want to know more about it, just reach me out. Certainly, we can give you a workshop or a 3 hours, like a kind of a seminar, or a lot of YouTube videos are there which we can share. Even in collaboration with CDAC, we did a lot of the workshops too. Those are the things already there available in the internet, which also you can go through it. Let's move on. So the example devices, that's what it is. These are the people working on it, working with us on that. There are a lot of devices already being developed, and you see it here. The edge device is already in place, and certainly these will take 3 to 9 months time frame, where you can architect and then send the chip for the fabrication. Once the chip is ready, you can start working, assembling the device with the the other PCB and make the solution ready for the whole product. And that's the kind of the idea to product. This is where it's happening. And like this, there are many use cases are there. One can start developing their own devices too at their students' time only. They need not have to come to the industry and work on this kind of stuff. During the students, the bachelor's degree only, people can start working with us and make products on their own. Idea to product kind of a concept they can have too. Okay, so how to collaborate with Open Power? And this is where join the foundation, engage in specific work groups. Yeah, we do have work groups where there are a lot of people periodically meet and greet and probably collaborate on some of the technologies whatever they develop, and then participate in power focused workshops which I mentioned, and also seminars, and speak at OPF and industry events. All these things possible with the foundation whatever I'm leading here. Next slide, please. So these are all the the key email IDs which you can ping, and you can share your ideas, or if you want to collaborate immediately there will be a response, and definitely you can create your own devices with our platform whatever we have innovated for the last, I would say, 12 years in Open Power Foundation. With this, I'm going to close my session here. Thank you very much. Thank you.
Well, thank you, sir, for such an enlightening talk. Your decades of experience and vision for AI and HPC have been truly inspiring for us all. I now request Dr. Satya Gupta, President, VLSI Society of India, and Ms. Chitra Hariharan, Secretary, VLSI Society of India, to present a memento to sir as a token of gratitude. I request Professor Gupta to do the honors, please. Professor Sudeep Gupta to do the honors, please.
Maybe you can keep this one picture. Let's develop a processor like this in IIT room.
Done. Thank you. Thank you. Thank you all the speakers and participants for an insightful session, attending so patiently. Let's now continue.
Thank you for a wonderful inauguration session where a lot of plenary talks were there. Now we will have paper presentation session, after lunch. We'll break for lunch, and after lunch we will continue at 2:15. There are 5 parallel sessions. 2 of the sessions would be here, and one in Majlis, one in Anjuman Hall, and one in Adab Arj Hall. And session E would be on the 3rd floor in the boardroom. Okay, so whatever session you want to attend, you can attend those sessions. There is one small change in the program. So previously at 3:30 there was a tea break, and then there was a talk. So that because of some unfortunate circumstances, a speaker could not come, so there would be no break after, so there would be no talk after that, and we will continue with the next session. And in the evening, there would be at 6:30, there would be banquet at the same very hall.
As you all know, for the banquet session, we have our banquet speaker. She's already here, Sarita. She's going to be talking about her startup journey. So please ensure that you are all attending the rest of the breakout sessions and the banquet session, okay? It's going to be an inspirational talk, talking through the product build journey, folks. So I would really want every one of you to be present and then attend and take advantage of it, okay? Thank you, everyone.
One more announcement. So there are 3 parallel lunch sessions. 2 are here and 1 is in Adab Arj Hall. So those who you feel it is crowded here, you can go to Adab Hall also. Thank you.